Okay, thank you for joining, everyone. I expect more people are going to filter through as we get going, but welcome everyone to this Handling Big Data Interactive Workshop. This is being held by the Institution of Environmental Sciences in collaboration with the Geological Society. We're really pleased to see so many of you here today, and we have some great speakers lined up, and also some really good interactive sessions. So it should be a really good opportunity to ask some questions and hear about some new work being done in this area. So I just wanted to go through the agenda quickly. We've got a really packed agenda today, so we'll move through it as quickly as possible, but we're also allowing for a little bit of breaks. So we'll do a quick welcome and housekeeping now, and then we'll move on to our first presentation, followed by a Q&A session. We'll then have our first interactive session, followed by a break, our second interactive session, and then we'll close off with another expert presentation. So thank you all very much for joining. In terms of the housekeeping, during the presentations, please do mute yourself and turn off your camera. This just reduces distractions whilst other people are presenting. It would also be great if you could use the chat function in a minute just to introduce yourselves, just so everyone knows who's joining today. As I mentioned, there's going to be plenty of opportunities to ask questions after the presentations. Please do so by using the raise hand function, which you can find at the bottom of your screen, or you can also enter the question in the chat box, and then the chair will ask these on your behalf. If you're experiencing any difficulties, please do write them in the chat box, and I'll do my best to assist you. So I'm really pleased now to hand over to Matt Wright. He's going to be chairing today's session. Sorry, bear with me, someone's just having a technical difficulty, no worries. Okay, thank you. So Matt Wright is environmental engineer from Golder Associates and the early careers chair of the Contaminated Land Specialist Group at the Geological Society. Matt, really pleased to hand over to you. Thank you.
Thanks, Stephanie. Yeah, big welcome to everybody on the call today from both the IES and GeolSoc and the Contaminated Land Group. Thanks very much for joining us for what should be a very informative and very relevant event discussing topics around big data. We, just to echo what Stephanie said, we have got some great presentations and the workshop should be really useful. And yeah, a packed schedule. So I think the best thing that we can do from my point of view is introduce our first presentation and get things rolling. So the first presentation is Big Data and Land Contamination Risk Management. It's been delivered by Nathanail, the GHD UK Technical Director. Paul is the Technical Director of Contamination Assessment and Remediation at GHD, a global company offering professional services in transport, industry, energy, property, and of course, environment. I like this a lot. Paul likens big data with the hubbub of a large party and data analysis with dancing. The more ways you dance with a partner, the better you get to know them. So it's just as well that he and his geologist and data scientist wife, Judith, enjoy dancing ballroom and Latin together most Friday evenings. No further ado, over to you, Paul.
Thanks very much indeed, Matt. And I'm going to strictly stick to the big data topic. No dancing involved at the moment, but I might get a few puns in. Good afternoon, everyone. First of all, I'm delighted that we are actually looking at big data in this way. And I have to say, I'm looking forward to the workshops that follow on, having had a sneak preview. There's some really good stuff coming up. But I'm going to put this into a land contamination risk management context and hopefully give you some tips and some things to think about when you are considering when and how to use some of the techniques that you will hear about later on today and that are available within the land contamination community. Picture on the right is one of my favorite images from the Hubble telescope. It shows deep space and it's almost the edge of time. And there are millions and billions of galaxies and stars out there, but there is a sense in there. And if you think about that, you end up with where C.S. Lewis called the numinous. So from the sublime to the ridiculous, Humpty Dumpty is quoted as saying that a word means whatever he wants it to mean, which isn't really a good basis for a conversation. So I thought we should at least try and understand up front what we mean by big data, and you'll see that I'm then going to put that into a land contamination context. That's the abstract that accompanies the program. So I'm going to talk to you a little bit about what tiny data is, and to remind you that what we're after is getting meaningful information to help us understand our sites better, to make sure that those conceptual site models are as good as we need them to be. And the way that we do that is by understanding the uncertainty in those conceptual site models, of which there are two types. There is epistemic uncertainty, stuff that we don't know well enough, but we could learn better if we went and took more samples, did more investigation. And then aleatory uncertainty, which is a function of the natural noisiness or variability of the thing we are studying, the arsenic, the methane concentration. Oops. And what we are doing in using data to populate our conceptual site models, and you'll see that really well illustrated later on, is bringing together tiny and big data. And that's not a trivial action. So the extraction of that data depends on really understanding your data, the kind of numbers, the resolution, the precision, what the columns are called, how they were collected. There is also some value in understanding how data science operates, the manipulation of information by a computer, by a database, by a piece of software, by your favorite R package. And one of the speakers may divulge what his knowledge of ab initio quantum mechanics is later on as part of that. So the third dimension of understanding your data and coming up with something meaningful, trying to listen into the part of the conversation in the hubbub of a party, is understanding the context in which it's being used. And in our case, it's about risk-based land contamination management. So you need to understand your data, you need to understand the maths behind data, and you need to understand the problem space that we're working in. So land contamination risk management, the guidance published by the Environment Agency last year, updated earlier on this year, adopts a stage approach, beginning with a preliminary risk assessment and then going quantitative with either the use of generic assessment criteria or site-specific assessment criteria, at the end of which you decided whether or not you need to remediate. If you are, you then need to decide how you're going to do your remediation. Then you invoke your Nike moment and you do it. And at the same time, you're collecting the evidence to prove that the remediation was a success. So that's land contamination risk management. That's the problem space we're in. Tiny data. So I've got tiny data at one end and I've got big data at the other end. Tiny data is where you've got such a small number of sample locations, analyses, that each item is precious. So you don't summarize it, you don't produce an average, you deal with your entire data set. And I've taken from the front of the statistics guidance that Claire published last year, a checklist of 7 things you need to think about before you open page 1 of that guidance. So before you embark on a statistical analysis, you're supposed to check the 7 things in front of you. I'm not going to go through them, but I am going to go to the last one. And that is that before you embark on any clever statistics, you need to be satisfied that the number of samples is enough for a statistical analysis. And if it isn't, well, anything you do after that is invalid and likely to get you or your client into trouble. So tiny data, we don't have enough to do averages and standard deviations and that kind of stuff. Big data we'll look at next. So the traditional way of looking at big data is through a series of V's. And originally there were 3: volume, velocity, and variety. More recently, another 3 have been added: veracity, variability, and value. And my title of the slide is 6 V's. But as I was putting this talk together, I realized that there was a 7th V that I wanted. So I've added one, and it's vintage. Now, admittedly, I was on a geology field trip to the Denbigh's vineyard on Saturday, and so vintages of wines were somewhere near the forefront of my thinking, but that wasn't really what I meant by vintage. So I've now really got 7 Vs. Velocity is about the rate at which data comes at us, and we'll hear later on about real-time gas monitoring. If you're a fan of the latest Apple iPhone, you've got LiDAR in your hand. We can video stream site visits. We can fly over our sites with an unmanned aerial vehicle. We can calculate, we can gather real-time dust monitoring data, as one of my colleagues is out on site at the moment doing. So it's the speed at which the information is coming at us. Can you keep up? Variety is about the location of your information, the time at which it was taken, the type of information, the entity that you are getting. Is it a concentration, a flux? Is it a leachable concentration? And then what about the metadata? Which laboratory, what method of analysis? Do you have the certificate of analysis? So there's a whole range of information that we need to deal with. And if you can't trust it, if it isn't good enough as a foundation for your decision, then we've got problems. So we have QA and QC samples and certificates of analysis, and asking the same question of the soil from a variety of different perspectives, which gives us redundancy in our analytical data. And then we have variability, the aleatory uncertainty I mentioned earlier. The concentration at one location is very different to one a meter away or 25 centimeters down. In the case of something like gas or a volatile, time will vary. And also the effect of the soil type. Contaminants behave differently in fine clays, sands, coarse gravels, and made ground. And so when you're looking at patterns in your data, you need to be careful that you're not mixing your apples and your oranges and trying to make something of them that isn't valid. The average concentration in the clay will be different to the average concentration in the sand, and the average overall may well be a number you can calculate, but one that is meaningless in practice. Value. Now, this was a new V to me when I put this talk together, but really it's about the relevance of a piece of information to your conceptual site model. Does it helpfully reduce the uncertainty in that conceptual site model? Does it make it a better basis for decision making? Why do we need that item of information, that concentration, that measurement? And what would happen if we didn't have it? If it didn't make a difference to the decision, we probably didn't need to collect it. And then vintage. The thing about geology is it changes, but not very quickly. So a geological map that might be 20, 40, 60, 100 years old, a couple of weeks' time, I'm going on the engineering group weekend down in Bath to look at some of the work that William Smith did over 200 years ago that resulted in the first geological map. And it's a recognizably correct map. So geological maps may well come from a bygone era. They may well not be good interpretations, but they're better than nothing. We have historical borehole logs from the 19th century drilling of water wells. We have different methods of analysis. We have different methods of data collection, codes of practice, and standards. Last year saw the publication of a new standard on collecting samples of volatile organic compound analysis, VS 10176. So old analyses of VOCs in soil won't be directly comparable with ones collected under the 10176 regime. You don't throw away vintage information, you just treat it with a little bit more respect, a little bit more caution, and perhaps allow it a bit more wiggle room in the interpretation that you place on it. So, we talked about land contamination. I've introduced you to 7 dimensions of big data, and I'm going to put those together. And what I've done is down the column, I've got, for each row, I've got one of my Vs, and I've left off my 7th vintage. And then I've looked at each of the stages of land contamination risk management: the preliminary, the quantitative risk assessment, the options appraisal, the remediation, and their verification. And I've asked myself what relevance there is at each of those stages. Do we have large volumes of data at the preliminary risk assessment stage? Well, the answer can be actually yes, because you're looking at everything that is known about that site. Does it come at us very quickly? Well, the answer is no. It will come at you as the email from Landmark lands on your desk with the zip file of historic information. By Jove, is it variable. You've got everything from historical land use, geochemistry data, aerial imagery. Do we have to evaluate its veracity? Yes, we do. It will have variable degrees of resolution, variable cartographies, and so on. The information will be varied. We might have street names that are of interest. We might have field boundaries we need to understand. And is it valuable? Oh yes, highly valuable at that stage. So I've done that for all of these, and since you're getting the slides, and I'm keen that we don't overrun, I thought it would be interesting just to reflect on the fact that by my analysis, the only place where I figured that big data as such didn't have any role to play was in options appraisal. I've got my conceptual site model, my risk assessment says I have a problem. I've only really got about 30 generic remediation technologies to play with, and shortlisting those is a relatively simple process. Now, the remediation design and everything else gets a bit more interesting. But you can see that big data has a real role to play at the risk assessment stage, at the doing and verifying the remediation as well. So it's something you're not going to get away from in your professional careers one way or another. So my role this morning or this afternoon was to set the scene and introduce you to some of the contexts and make you think as risk-based land contamination managers. And I'm going to stop there and take any questions. And I've got another slide I want to show you before we sign off.
Thanks very much for that, Paul. That was really interesting and great, yeah, scene setting. So if anybody's got any questions, feel free to just unmute and, sorry, raise your hand and ask away, or you can put one in the chat. Happy to do that and pass that on for you. So yeah, ask away.
Okay, while people are thinking of that, I'm going to try and share my final slide. I'm going to do a bit of advertising. Next week in Italy, an online remediation conference called RemTech is taking place. Next Thursday and Friday, I'm one of 4 people running a 24-hour sustainathon, looking at progress on the Sustainable Development Goals around the world, and that's the flyer for it. So I'm going to leave that up there as a bit of background marketing for a free event next Thursday and Friday. I'll just go to the chat if there's anything there. Matt, you may well want to redeem your time and move on.
I had one quick question for you, Paul, if nobody else has got one. When you're evaluating historical data and you say treat with caution, what sort of red flags are you kind of looking at in terms of, what data should we be disregarding versus?
Okay, so let's take geological maps as a starting point. The language of the map and the interpretation that's embedded in the cross-section will have been very different pre-plate tectonics becoming mainstream and post-plate tectonics. For the non-geologists, the legend, the names we give to different layers has changed in some cases over time. So the most famous example is the Kuiper Marl is now known as the Mercia Mudstone. So looking at those kind of vintages, when you're looking at a borehole log, understanding the purpose for which it was constructed, and if it's an engineering geological borehole, which is probably the most useful thing we could have, is looking at the description and working out what version of BS5930 was in place at the time, so you can interpret what the material looked like. In terms of data, chemical data, just been looking at some work I did 25 years ago in the early 1990s for some environmental work up in the northwest of England. And I wrote the database for reporting some really deep boreholes with lots of analyses of groundwater chemistry. Without understanding the equipment and the methods of analysis that we used, you can't really compare those concentrations with samples taken from the same locations using today's kit and today's methods of analysis. So it's understanding the baggage, the CV of the data that you're looking at.
Brilliant. That's really helpful.
Time to ask a question, Wayne here.
Yeah, please do.
Hi, Paul. You okay? So I'm next week. I'm going to talk about the groundwater spatiotemporal data analysis tool, right? And lots of what you said are pertinent to this tool in action. Okay. One of the challenges we anticipate facing in the future is adoption and trust of the underlying statistical methodologies by, say, environmental regulators. So case in point, for example, right, a lot of the work that's taken hold and a lot of the methodologies in the space of network optimization, so case in point, things like well redundancy, sufficiency and stuff like that, they've kind of relied on perhaps not the most sophisticated statistical analysis, but where they maybe don't have the sophistication, they certainly are intuitively understandable, right? And this is what I think the environment regulators like, is to have that intuitive feel. Now, as we move into the realm of kind of big data, we're going to be using, more sophisticated data science tools, right? In your experience, how do you bring the environmental regulators with you on that journey to build that trust in the underlying methodologies?
I'll give you the fiver later, Wayne. That is a fantastic question. My answer is start with where the regulator is and the question that they are being asked by planning or Part 2A of the Environmental Protection Act, and write your conclusion in the language of the legal context that the regulator is regulating through. So in a Part 2A context, you conclude the evidence indicates that there is or is not a significant possibility of significant harm or pollution of controlled waters in your case. In planning terms, the conclusion needs to be, and the risk assessment has demonstrated that the site isn't suitable for its intended use, but if you do this, this, and this remediation, it will be made suitable for its intended use. So the regulator will understand that the answer given is an answer to the question that they are being faced. And then they will work back and look at the trail of evidence. And so when you're presenting data analysis, it's not enough to simply present a really good contour plot, for example. You need to show the evidence on which that's based. So what are the control points? What method of contouring did you use? If somebody's used kriging, but they haven't reported the variogram that they fitted to the data, little alarm bells ring. So it's almost like, if you remember being back at school and doing your maths problems, it's showing you're working out so somebody else can follow your logic. And if that's done and done properly, the regulator will be satisfied. And if they're really out of their depth, they will go and get an independent reviewer to look at it. So that transparency, I think, and couching language in the legal context that the regulator is living with and working through are the two things I would say people should do if they want to get their reports accepted more simply, doing it right first time through the systems.
That's great. Thanks, Paul.
Thanks very much, Paul. That's really great. So yeah, I think it's probably time to move on to the next presentation now, if that's all right with everyone. So our next topic is being delivered by Wayne Jones, who's the Principal Data Scientist at Shell, who you've just heard asking a very good question. The topic, he has a BSc degree in maths from Bangor, University of Wales, and a MSc in mathematical modelling for industry from the University of Loughborough, and a PhD in ecological modelling from the University of Strathclyde. Wayne became a chartered statistician in 2008 and a Shell Principal Science Expert in 2019, and is going to be presenting on the GWSDAT tool. And over to you, Wayne.
Cheers, thanks. Can you see the screen? And can you hear me?
Yep, that's all showing fine. Thanks, Wayne.
Right, okay, and you can hear me.
And I can hear you, yeah. Thank you.
Very good. Anyway, yes. Okay, so I'm going to be, thanks a lot for the opportunity today, guys, to talk about GWSDAT. I've spoken about it before. It would be interesting if people could put in the chat whether they have heard of it before, right? It's just like a quick straw poll, effectively, just to get us an understanding. A little bit about ourselves in Shell. First and foremost, we have a very active soil and groundwater network. We look after a large portfolio of different sites, whether it be the smaller kind of retail sites that kind of goes to the tiny data sets that were spoken about earlier, and then to the more larger refineries and terminals, etc. Right? We have we typically engage with environmental consultant companies, and they go away and do the surveys and do the reports effectively, right, and feed that back to the environmental regulators. We're very active. Also in R&D, and GWSDAT has come about from a joint project with the University of Glasgow, and that's been going on now for almost 10 years effectively. We like to work in an open and transparent manner as well. So GWSDAT, what is it? So it's a user-friendly open source decision support tool for analysis and reporting of groundwater data. It's designed to be easy to install, quite intuitive to use, and it only requires a standard monitoring data input. So a little bit about the history is basically it was principally designed for the retail networks, right? So this is the smaller sites where it perhaps wasn't worth the effort in moving that into a full ArcGIS system, right? So that's where it was actually came about. It's grown in scope since then, and it works equally well for the larger sites as what it does for the smaller sites as well. I'll just put the video on there. There's a variety of different ways you can input the data now, and we'll show some of that in the interactive demonstration. The holy grail that's not there at the moment, which can be done, but we're still waiting for it, is directly into database. I think that's the next big thing in GWSDAT in terms of data anyway. It's been used now for over 10 years in Shell, right? Typically in its combination of refineries and terminals and all the rest of it. And we did a survey, and there was 4 common themes where the benefits came out of it. So supporting design optimization and monitoring remediation programs, so we avoid collection of redundant data, and we want to know where. So it's very useful actually in knowing where the weaknesses in your monitoring program is. You can spot early identifications of new leashes quite quickly, right? And the way that we demonstrated and promoted GWSDAT to begin with was, we actually went out there, asked people for data, put it into GWSDAT, and then fed back the results. And even in that small exercise, we saw things that we hadn't previously seen as well. So that's good, immediate impact. Rapid interpretation, right? Once you've gone through the burden of actually getting your data in the particular format, whenever you're doing the sampling round, you can just append it to the bottom, click the button, redo the analysis, and you can slice and dice and basically produce lots of different visualizations and reports just with a simple click of a button, right? And again, I'll show you a demonstration of that working in action very soon. It's been around for a long time now, and it was a very good strategic decision to make it open source, I think, right? You know, because it's brought lots of people on the journey with us, okay? And just like you to point to this GWSDAT.net case studies, we've got more than 10 case studies there, ranging from our own, US EPA, for example, Exxon, and even training videos that Indonesian sort of student society has done, right? So it's its reach is expanding a great deal. And also, one thing that's hot off the press here, we're trying to publish a paper in groundwater monitoring and remediation, which basically highlights some of the use cases. What we've realized in terms of the literature in this space on GWSDAT, which we think is important for credibility and transparency, for example, is, you know, there's lots on the technical background of it, but very few on the use cases. So watch this space. In the future, we're hoping, touch wood, we can get some use cases out there. GWSDAT is accepted by some of the regulatory agencies, right? So there's a link there to the UK environment agencies where they actually call out GWSDAT and say, you know, this is the tool that we basically advocate to use in these situations, right? We're doing a joint webinar with Herb Levine from the US EPA next week as well, you know, and that talk about some of the Plum diagnostic tools, which we found very, very useful. There's a good use case there on that. So it's wide, its reach is expanding globally, basically, and it's continuing to expand as well, which is good news. There is a LinkedIn group, guys. If you just search GWSDAT on LinkedIn, feel free to go ahead and join the group, and we're hoping that we build a community-based support model. You know, as we get more and more users, we want the community to be able to answer the questions rather than just be funneled through me and my colleagues effectively. Right, so GWSDAT is all about trend analysis, interpretation of what's happening at your site, and we use smoothing statistics mostly to do this, right? We do smoothing statistics on basic time series plots. So this is this is basically a well time series, okay? Lots of the historical analysis or traditional analysis just fits a linear fit to it, right? Now, we think there's some more complex things going on, and one of the bad things about just a linear fit is just this, you know, it's monotonic, right? You can only go one direction. So we use smoothing local linear regression statistics there to pick up the different trends. We also do spatial statistics, most notably for groundwater elevation data. So we fit like a smooth kriging surface, more or less, to that surface to fit to the groundwater elevation. But what we do for the groundwater concentrations is this is very unique. The unique aspect of GWSDAT is that we do spatiotemporal statistics, right? So the way the industry typically works is, you know, we do a sampling round, sample concentrations across the site and do a krigging for krig the surface here, effectively just fit a spatial surface to it. And then we'll repeat that exercise independently for the next sample round and again, right? GWSDAT does it differently, right? Instead of doing 3 independent models in this use case, it does it in one spatiotemporal framework. And there are benefits in doing that. Most notably, it's about the amount of information you gain out from that complete data set. You get more information out from fitting one spatiotemporal model than 3 independent ones, basically. GWSDAT has got some Plum diagnostic tools in it, right? So what this means is it has the ability to automatically track the plume mass, plume area, and average plume concentration. And you need to do very little, basically, right? All you need to do is click a button, and if the plume can be delineated without going outside the site boundary, in other words, you can get a closed kind of loop, effectively, it will calculate these quantities. And again, I will do an example of that before long, or you will do an example maybe of that as well. And it follows the RICA methodology, basically. So what it does is it takes this surface and it basically just numerically integrates under that curve, effectively. You also notice there's a cross right at the bottom there. That's pointing the center of mass for that plume as well. In terms of going forward and what the major future direction of GWSDAT is going to be, it's about network optimization, right? We'll reference this paper here, and what we do is quite a technical study, right? It's about where we actually compare with simulations of groundwater plumes and real data set, what the difference is in doing, you know, independent spatial models versus one spatial temporal model, right? And you can see that basically you get more information using fewer observations with a spatial temporal model, right? And of course, the people that are using GWSDAT already get this benefit, right? Because it's adopting that spatial temporal framework. And this is what, you know, my kind of mission is trying to push the benefits of spatial temporal analysis in this domain effectively. We've got a new PhD student, Peter. He started back in last year, actually, and it's on implementing cost-effective spatial temporal approaches to optimize groundwater monitoring network design analysis. So basically, he's going to be looking at bringing more tools into GWSDAT, like well redundancy, or more sophisticated well redundancy, well sufficiency. In other words, where if you had to build a well, where would construct a well, where would it be? Sampling regimes which take advantage of the kind of spatial temporal network, etc. So there's a lot of work that Peter's got on his plate there. Very hot off the press, there is a new release of GWSDAT. It's only been released last month. It's version 3.1, and it's basically the beginning of that journey into the network optimization tools. Here's a list of the new features, but I guess the main one is the well redundancy analysis. I'll give an example in an interactive session coming up, but it basically allows the user to very conveniently drop a well or a combination of wells from analysis and investigate the resultant impact. And this, again, alludes to the question I asked earlier, right? This is the kind of thing that regulators like, that intuitive feel. This is with the wells, this is without the wells. What's the impact, right? And, you know, even though the underlying methodology, statistical methodologies are quite complex, the takeaways, the way that you do the analysis and do the comparisons quite intuitive, right? It's that leave one out. And that's why we sort of started introducing these tools to begin with, rather than come out firing with, you know, sort of very, very, very sophisticated techniques. We've completely overhauled the user manual. It's online now. I'd encourage you guys to go and have a look at it. It was long overdue, basically. We hadn't updated it in quite some time, so it's well up to date. We've got a new Excel add-in structure. The old underlying technology, there were some problems with Microsoft typically used to block it the way it was previously, but hopefully now it'll be more robust and easier to install, and it'll look nicer with some nice menus. We've updated the branding to be more consistent with GWSDAT.net. The old kind of Excel templates looked a bit dated nowadays, so we've refreshed that. In response to user feedback, we've given the users the ability to change and set the color keys for the spatial plots as well. Some people weren't using GWSDAT because they couldn't get the results of GWSDAT analysis back into ArcGIS. So one of the things we've also included is the ability to export some of these plots in TIFF format, for example. There's the whole host of other minor bug fixes enhancements. I'd say the biggest one that is on the data entry, okay? So data entry in version 3.0, it didn't give the user much help on why it might have failed, right? So hopefully now there'll be more information, say, oh, right, you're using the wrong units for the groundwater concentration, or you're inconsistent units, or you've got this many bad values and all the rest of it, okay? So there's more data, metadata about the quality of your data that you're inputting into GWSDAT. Okay. Right, so this is normally where I just fire all guns blazing into the demonstration, right? But because this is trying to be an interactive session today, we're going to do this a little bit differently, okay? I'm going to give a little introduction to the tool, in terms of the data types first, I think. Yeah, if I can just go off screen. I don't know why. Yeah, here we go. So, hang on, it's just hiding the menu at the top, is hiding it. So let me just give you an example. This is an example GWSDAT input data set. And before we do the interactive session, I just want to run through what the format of this data is. There is some pre-populated data out there for you. You can have a look, but it's useful to go through the different formats, etc. Effectively, there's a minimum of 2 tables you need to populate. One is the name, there's the well coordinates table, basically, and it's the name of a well, unique identifier for that, together with an XY coordinate for it. The way GWSDAT treats the coordinates is basically Cartesian, what we would refer to as Cartesian coordinates, which basically means a unit in the X direction has got to be the same unit or close to the unit in the Y direction as well. You can choose different aquifers as well. The analysis only gets done on an aquifer by aquifer basis, but it's useful to have, you know, the data set in one place, and you can just do the different aquifers. And again, I'll show that happening later on. I suppose the main table is the historical monitoring data table. You've got the name of the well, and it obviously must match with the name of the well here. You've got the constituents, and you can put anything you like, whether it be benzene, toluene, just make sure you're consistent, right? And case sensitivity shouldn't be an issue, but just make sure you call it benzene all the time. The only things you can't use are GW, right, which is saved for groundwater elevation. So this is where you basically put the groundwater elevation value in here, and you can choose the units. It could be one of level, which is or millimeters or feet or whatever you like, and it's, you can put any units you like as long as you use a consistent baseline, right? It could be meters above sea level, etc., whatever you like. And the other thing we can put in there is NAPL as well, right? So NAPL is entered as a thickness, basically, as well. But other than those 2, you can put anything you like in there in terms of concentration, call it what you like. So, for example, here we've got benzene. On 31st of August, Halloween 2002, basically 78 micrograms per litre, yeah? And you can choose, there's different units here, and you can use milligrams and nanograms, stuff like that, but when you input it, you have to use a consistent set of units for the different contaminants as well, okay? Non-detects are handled with substitution, so when we kick off the analysis, it will ask you in Excel mode anyway, right, whether you want to do substitute the full non-detect. So in this instance, it would be using a value of 10, or the default value is actually using half the detection threshold, like so. So you can see how you incorporate non-detect is ND less than the detection limit effectively, and it'll pick that up automatically. This is the basic example. There is a more sophisticated example as well, okay? This one includes, say, electron acceptors and some emitted data points. It also, you have the ability to include a shapefile as well, right? So this has the ability to overlay a site map onto it, and this is what our consultants and users GWSDAT really like a lot. It really helps in terms of the interpretation of what's happening at the site. Before I kick off, are there any questions? Let me have a look at the chat. Heard of it, not used it, heard of it, not used it, not used it. So feel free for anyone to sort of ask questions as we go along, right? We want an interactive session effectively. So go ahead and ask any questions if you so wish. I'm going to go back to the exercises now. So I'm hoping that some of you might have looked at the getting started section. Okay, so let's go to that. GWSDAT. Oops. Here we go. So please excuse an auto broadband taking its time. So you can download the user manual there, and you can download the example data sets from there as well. I've done this already into this folder here, and you can see this is what, once you download a zip file, and you can unzip that like so. And we're going to do the tutorial questions together. Right? So I'm going to share a couple of links on the chat, if I can get the chat. Oh, I'm not sure where the chat, here we go. So there's the link for getting started. I'll also send you a link for the actual tool as well, which will should be at the bottom here. Or here we go. So here's the actual link for the tool as well. So if you guys are able to have a look at the user manual, download the data sets, go into here, and let's do these steps together, basically. Okay, so first step is read the background material and watch the webinar. Basically, I'm hoping you've done that before, right? So look at section 4 of the user manual. Okay, which is basically, copy the user manual here. So this is basically on the input data format and all the rest of it, right? Use the online version of the user manual, input the CSV well coordinates and historical monitoring data sets for the basic example data set. Let's just do this, right? Let's do this example. Okay, now I'm just going to I'm not going to use the online version. I'll tell you why, because I want you guys to use that. I'm going to use it, look exactly equivalent, but please go ahead and try it using the online version as well. I'm just doing this because it's quicker. Right, okay, so this is what you're faced with when you first log in to the online version. To import the CSV file, right, you just click on import CSV data here. This will bring you to a different screen here. You can give it a name of a data set. I'm going to call it Big Data Workshop 1, and you just browse for the monitoring data file. Okay, so I'm going to do the basic example. It's all there for you. So let's do basic example well data. There we go. It's put it in, it's read it in, and you can see you've got a visualizer which lets you know what it looks like effectively. Yeah, same thing exactly for the well coordinates file. There we go. And lo and behold, right at the bottom, then when you're actually happy with it, you can browse it like so. You can click import like so at the bottom, and that will bring it in into the sort of data manager. Right now, you'll notice that there's a couple of their examples there as well. But to go ahead and do the analysis, you just actually click analyze like so. There's your data set. There's no aquifer in this example data set at the moment, so you just click select, and there you go. There you go. It's imported that data from the different CSV files, and it's conducted a GWSDAT analysis on this as well. Okay. So before I go into the demonstration, so I'm going to give a demonstration of the tool now, but I would like you to read the question, the next part of the question here, and bear that in mind to answer the next one. So using the graphical user interface, can you identify the constituent and well combinations where concentrations look to be rising quickly? For xylene, can you produce a time series plot of Plum diagnostic quantities of area, mass, and average concentration? Okay, so that's quite a good one, right? That's a good couple of questions. So let me give a quick demonstration of how the tool works effectively, and then I'll answer those questions as part of the demonstration. Okay, so the first plot you get is the spatial image plot. Basically, the black dots represent the well locations, the sampled values above the well locations, and the name of the wells below that. You can overlaid is the predictions of the spatiotemporal smoother, right? So this is this 3-dimensional smoother, not only smooths in space, but smooths through time temporally as well, right? And you can move forward and backwards in time using that, and you can play it as an animation like so. Yeah, it takes a bit of time to update the comment. Yeah, you'll also notice that there's some blue arrows here. This is the groundwater flow direction and strength as measured from the imported groundwater elevation measurements as well. You can actually add that as well, add a groundwater contour onto that. And the blue arrows and the contour are actually done in two different methodologies. You can see in this example here, they're all pointing in the same direction, right? Which is multiple lines of evidence saying the same thing. Lo and behold, you can see in this example here, the groundwater direction is predominantly towards the southeasterly direction. I'm going to turn that off for now, basically, as well. With a click of a button, you can actually just click that, and what it'll do, it will generate a PowerPoint slide pack, which I'll open like that. And you can see it's appended all the plots one over each other, and this is the kind of stuff that typically gets appended into GWSDAT reports. Or there you go. You can choose the different solutes. This is benzene. We can do xylene or any of the other ones there as well. You can change the different concentrations, units. There are also kind of bubble plots. If you don't trust the spatiotemporal model for any reason, you can always fall back on just basically graphical depiction of the observed data set, basically as well. There's even a black and white color scale as well, which is useful when plotting, printing out these types of graphics on black and white printers. What we found is, these, if you print this in black and white, it doesn't naturally sort of translate very well, right? So it's a useful addition later on there as well. And you can also turn off the groundwater arrows as well. Yeah. So on this tab here, what we have is the plume mass and area concentration. So I'm going to choose xylene here, and it's going to answer one of the tutorial questions effectively, right? So you can see just by selecting this tab here, what it's done is, and click plume diagnostics there, it's basically delineates the plume using a concentration value of 10 micrograms per litre. You can change that as well to what you see fit. And you can see, because it's managed to delineate that plume without going outside the site boundary, it's produced some plume metrics, namely plume mass, plume area, and you can see the centre of mass there. By clicking this tab, what this does is it effectively does that going through time. Okay, and what we found is that's more useful than just looking at the evolution of the individual spatial images, basically, right? So that's question number one, or question number two from the tutorials answered effectively. How do we get a time series? Well, it's easy peasy, right? You just click this tab here and it'll do it for you effectively. Yeah, and you can see.
There's one question. Someone's saying in the chat box that they get an error command non-numeric argument. I'm not sure if that's something you could address.
I get an error non-numeric. Oh, I've not seen that one. Is this on the online version? Is it? Maybe on no local. Oh wow. Okay. Well, maybe we can take this up. Or do you want to share your screen, or how do you want to do this? Can you provide a bit more details?
Feel free to unmute yourself, Bassett, because then you can just talk directly.
Is this for the example?
Screen now. 1 second, I'll share my screen. If you can.
Let's do it.
But will that gonna take a lot of time?
Is this with the example data set? Is it?
Yes. Yes, it's for the example data set. Before the session, I had actually tried, and I did get the picture and representation and stuff. But then, while during the exercise, when I uploaded the data, it was showing this error, non-numeric argument to mathematical function. That was the error command I got. And now when I try, even for the old, for the basic example, even if I select that, I get the same error. For spatial image, yeah, I get non-numeric argument to the mathematical function.
Yeah, I don't know what's happened there, right? Maybe it's best not to share that now, right? If you can...
Yeah, because that could be difficult sharing my screen here.
Yeah, it was. Yeah, I think something's gone on in installation basically as well. I would try the online version for now and see how that works for you.
Okay, I'll try the online version. Yes.
Let's go back to thank you for asking the question, right? That's good. This is the kind of thing we want. Just to also highlight the well redundancy feature in GWSDAT as well, right? You know, if we look at this plot here, this is a spatial image. You can click the well redundancy tab and you can basically get rid of a well. Okay, so I'm going to do that in this example here. Oh, that's never happened to me before. I'm getting the same thing. Huh. Oh, there it is. Strange, because I've never had that happen before. Oh. Anyway, something must be happening. I would try again, right? Because that seems to have worked now. But basically what's happened in this instance here is I have selected monitoring well 4 to be dropped, right? And you can see monitoring well 4 is grayed out and it refits the model and shows the results of the refit model. And if I toggle between them, you can see the impact of dropping that well from, and you can see in this instance doesn't have a great deal of impact, right? Now, when we go back to the plume mass, area and concentration, what it will do now is not only will it calculate these quantities for the full data set, but it'll actually calculate the quantities for the reduced data set as well, right? So the full data with all the wells is in black, and the green one is it represents the reduced well data set, where in this example, I've got monitoring well 4 omitted, right? So you can see in this instance here, you know, by dropping monitoring well 4, what happens is that the plume mass and plume area go up slightly. Basically, the average plume concentration doesn't change a great deal, but it just goes up marginally, right? Is this evidence that we can get rid of monitoring well 4? It would probably be some kind of evidence, but you'd probably obviously need more supporting evidence as convincing regulator that you can drop monitoring well 4 going forward effectively. Yeah, there are additionally some tools here called estimate boundary, and this helps you pick a suitable kind of delineation, plume delineation threshold value. The value of 10 micrograms generally works quite well, but you can tune that a little bit, and this gives you some help in doing that.
Sorry, Wayne, there's a couple more questions in the chat as well. Some people saying unable to calculate plume statistics for a threshold value. Yeah,
I would make sure you choose. And so here's the, if you, oh goodness, hang on. If you choose xylene is the key here, okay? You need to choose xylene, because if, so you can see with xylene, you can get this delineated plume that doesn't go outside the site boundary. If I choose, for example, benzene, okay, what you can see that the plume isn't fully delineated with the site boundary. So when I do that, you get unable to calculate it, right? It needs to be completely within the site boundary, basically. Yeah, I think that answers that question. All right. Cool. Okay. All good?
Yeah, that's good.
Cool. Right. Okay, I'll carry on, right? But good questions, good questions. So that's mostly it about the spatial plot. Let's go to the time series, right? So this is what I spoke about earlier, is where you can basically, this is where you can basically choose different metals and substance combinations and just drill down into individual wells, right? You can see the data here for that well is in black. Non-detect data actually gets plotted in orange, and we've overlaid the predictions of a one-dimensional smoother to it, right? And I think this is where it's key about the difference between fitting a smoother function as opposed to a linear regression. The interpretation from the linear regression is just flat and straight throughout the history of the well, right? But in reality, you know, I'm more inclined to believe this, which is saying, look, it increased rapidly and is gradually going down in time. Yeah, there's various different options like showing a legend. You can also overlay the groundwater elevation on on the right-hand scale there, and that's useful for picking up correlations in groundwater elevation and concentrations, basically. Yeah, there's also another functionality here which does the more combined. It's called the well report, and this menu here. And basically, you can choose to overlay multiple substances or solutes, right, in a grid-like structure. So you can drop any combinations of wells. You can update the plot. You can choose different solutes, right? And you can look for the correlation between different solutes across the different wells. If you just choose one substance, it does something slightly different, and it will also give you this smoother results on it as well. You can turn that off at any time you like as well. So that's good, right? It's one of my favorite plots because it plots everything basically in a single plot. It's very concise. Yeah? The kind of thing that used to take ages to do in Excel, right? So even on that basis alone, in terms of producing graphics and display plots, it's very good in terms of saving time. Other tab here is a trend and threshold indicator matrix, right? And this is going to answer question number 2 or number 3. What we have here is a matrix plot, right? The columns correspond to the different solutes and the rows correspond to the different wells. And what this is doing is it's looking at each one of these individual plots here, and it's calculating the gradient at your selected time point here. So this is at the end of after the most recent sampling. It's looking at the gradient at this point here and reporting it back using this color code here. Strong green or dark green means it's coming down quickly. Strong red means it's going up quickly, and white is approximately flat. It's gray if there's no data to calculate it, and it's blue if it's non-detect, right? I think it's safer just to report it's non-detect rather than start interpreting trend from substituted data, basically. Yeah, and you can see here in this example here, we've got 2 reds, right? And that's benzene, monitoring well 7 and 11, basically. So if we drill down back on them, look at number 7. There you go. Lo and behold, you can see that it's in this well here, it is going up very quickly. Monitoring well 11, it's still going up very quickly as well, right? So this is a high level, high throughput check on all the different combinations of wells and contaminants, where you can identify the problem wells, basically. Yeah. There are a variety, so that answers question number 3. Okay, so the answer to that question is benzene and monitoring well 7 and monitoring well 11. Let's go back before I do some more. Let's familiarize ourselves with the next questions. Using the online version, loading the previously saved GWSDAT session, basic example, how do you save a GWSDAT session in RDS format, right? Well, with the online version, let's do the comprehensive example. Can you plot an apple thickness and repeat using the Excel-based menu, right? Well, let's find out more about the tool first. So I've talked about the well report, okay? There's also a goodness of fit check here called spatiotemporal predictions, okay? And what this does is, for a predefined solute, it plots the data, but then it overlays through time slices of the wells the predictions of that spatiotemporal smoother, right? So the spatiotemporal smoother has got to do a lot if you think about it. It's got to fit, it's got to smooth out all the data, not just spatially, but through time as well. And this is basically a goodness of fit check, just to check that the underlying spatiotemporal model is truly representing the data that it's seeing. Okay, it's not an interpolation method, so it doesn't go through the data points. That's what some people get a bit surprised about, but you've got to check out for systematic bias, right? And all in all, in terms of predictions of the model, it's doing quite well at the well locations. The only thing you might want to be slightly careful of is it tends to over-predict in monitoring well 1 and tends to under-predict in monitoring well 2. Okay, so there's some systematic bias there, but there's nothing to be alarmed about in this picture here. What you're looking for basically is big gaps between where the data is and where the model predictions lie. That's what this is most useful for. Again, I alluded to earlier, there's a customized color key here where basically we can You can choose and customize the menu, the color scheme in the spatial plot, any way you see fit. So I've updated it for xylene. I choose xylene again here, and you can see that's been modified to 2,500, where it was previously 3,000. I would warn against, using too fine a resolution, right? Because you might be over-interpreting the results of the modeling, basically, right? The variability might be fairly high in the measurements or what have you, so don't be careful in over-interpreting the model, basically. There's a variety of different options here. This is where you can choose the different options in terms of there's some related to images, there's some related to the Plum threshold values. I think the most important here is on the model settings, on the resolution of the model, right? So we've controlled and picked a kind of happy medium value for model resolution, right? Now, model resolution is the kind of complexity that your model will allow, right? And we've picked the value, default value, which is equivalent to this one of the parameters having a number of seconds equals 6. Tends to do quite quickly, etc. But we can up that, right? And sometimes that when you see numerical difficulties, the best thing to do is, and I'll talk about this at the end, hopefully if we get time, is up the modeling resolution, basically, right? And what this does is it basically takes longer to fit, but it gives the model a bit more flexibility to capture the main features in the data. And typically what we get this statistical anomaly called ballooning sometimes, which is basically where the model hasn't got enough freedom to basically fit the distribution it sees, and it kind of snaps in some places. Yeah, so that's a useful tip there, right? Go anything's anomalous, then go and up the model resolution. You wait a bit longer, but it'll probably be worth it. And the other thing I haven't done, which answers question number 4, is save session, right? So what this is kind of useful, you just click this button here, save session, and it downloads it like so. Yeah, and it's in the RDS format, which is basically a data format related to the R statistical programming language, which is what it uses behind the scenes. If you want to go and, I'm going to close Excel down now. I'm going to close it down, close the analysis down, and I'm going to basically read this back in again as well, right? So I'll probably do it in the online version. Let's do it on the online version. Just re-kick off the online version, and I'll show you how to import that. Just takes a little while to get going. So if you do load data here, is it? Yeah, load data. Yeah, and it should. I'll do this. I'll do this on my local version because it'll be quicker. So you can browse for your RDS file. Here's one I did earlier. There you go. It reads it in. You can click. It's even picked up the name as well, right? Big Data Workshop 1. Let's add the data. Click Analyze. And there you go, right? And one thing you'll notice as well is that it's read in that session data, and it actually, kept all the settings as well, right? What you previously saved, all the rest of it. I think this is very useful if you've got multiple people using GWSDAT. You can basically just save it off as this RDS file, and away you go. Email it to someone, they can pick it up and read it and import it very quickly, right? And that's very useful for analysing data sets, etc. So that's question number 4 answered. Yeah. So using the online version, loading the previously saved session, I encourage you guys to do that. Basically, save off a session, save it to your hard drive, go back to the online version, and away you go. Oh, so question number 5 then, with the online version and the comprehensive example data set, use the import Excel feature to perform an analysis of this data set. Can you plot NAPL thickness Repeat, but this time include a base map with a site by incorporating shapefiles located in the GIS folder, right? Whew, this one's a tough one. So let's go to, let's do this for the online version actually, just to be sure. Okay. So, God, it's a bit slow, I think, because no, let's not do this in the online version. I'll tell you why, because I think a lot of people are using it. So let's just do this. It's exactly equivalent to the online version, basically, but let's do import. So if you want to bring in an Excel file into the online version, it looks a bit like this. In fact, this is exactly the comprehensive example, like so. Just do import Excel file. I'll browse to the Excel file. So this is it picks up the .xls file. So it's a comprehensive example. It's there, downloaded from the website, and there you go. You can import it. You can see it's got the well coordinates, the monitoring data, the well coordinates, and all the rest of it. Okay. I'm going to go ahead and I'm just going to import the shape files now as well. The difference is with the online version versus the Excel file is in the Excel version, all you need to do is basically tell it where the main .shp shapefile is. The shapefile is not one file, it's actually a collection of files. And let's show you actually where it lives. It lives in the GIS folder here. And you can see it's got this .shp file, right? That's your main shapefile. And in the Excel local base version, it picks up that one and it'll pick up all the associated ones as well. In the online version, you need to pick them all up. And I'm going to show that in action now, right? So let's browse the GIS files. I'm going to select them all like so. And there you go. It's imported them. So I'm going to import that one now. Right, so in this data set here, right, it's realized that there's NAPL measurements as well, okay? So now NAPL, by its nature, it means that there's a lot of contamination around, and actually if you send the groundwater samples to the lab, you don't get a value because it's too high, right? Now, this leaves a bit of a quandary. We know there's a lot around, so what we do in this situation here, if we emitted it out, you would have a very biased view of the site, right? So what we do to try and address some of that bias is basically offer the users the ability to substitute those NAPL measurements for the concentrations at highest level values it's seen, right? So it maintains and tells you there's high concentration results, and hence why you get this question coming up. So I'm going to go yes. Again, this is all completely documented in the user manual as well. Okay, so it was area A, or area A1 rather. So I'm going to click this one. I should have done it, given it a better name, I have to admit. And there you go. This is the comprehensive data set, right? So you can see that those shape files have been read in, and you can see that that's been overlaid on the spatial plot as well, right? Consultants really like this, right? Because it gives them that, additional context you just don't have without that base map as well. A bit conscious of time, so I'm going to try and crack on now. I suppose, what was the question we had to ask, right? The second question, the fifth question rather, was, can you plot NAPL thickness? Okay, so the GWSDAT is geared up towards the spatial distribution of concentrations, right? But we want to plot NAPL thickness. You can find this in the plot type here, and it's the NAPL. It's called NAPL circles. And what this shows effectively is size scale, color coded NAPL bubbles. And here's an example here that you can read off the thickness on this chart here now as well. Okay, so you can plot the distribution of NAPL across the site, and you can animate it and change it through time any way you like. So it's like so. Right. So that answers question number 5. I guess the only part left here is to do number 6, right? Which is basically give you an example of doing this in Excel as well, right? So we read in the raw CSV files, we read in the Excel files, we read in the RDS files. I just want to show you the how we would do it in Excel, right? So this is what the Excel add-in looks like. I've pre-populated, these example data insights. This is what the add-in looks like. The user manual is there online. To do analysis, you click and analyze, ask you to accept terms and conditions. You're given a set of options. I suppose the most important ones are handling the non-protect. You substitute with half detection limit or the full, and you use the default or high modeling resolution. You can change the modeling resolution within the app as well, basically. So I'm just going to click OK. And how this effectively works is a lot like it's exactly like the CSV one. It grabs this data, produces the relevant CSV files on your temp directory, and it produces a script, and that tells R where to go and pick up these files from, and that's why it's exactly equivalent. So yeah, so the Excel front end is a bit of a it's a bit more sophisticated. It looks more sophisticated than it actually is, basically. And again, you can see that you've got this analysis exactly equivalent to what it was previously as well. I'll just finish off by doing the comprehensive examples. All exactly the same. You can see that in this instance now you've got the NAPL measurements, NAPL thickness measurements as well, and you can see here 19 millimeters here on the 29th of July 2009. The difference that I said previously is that you only need to give it the .shp shapefile and he'll automatically pick up the rest. That's one of the major differences in the Excel, because this is local. It's picking up from you can get access to your local directory and it can pick up all the necessary files as well. The online version can't do that. Okay, you've got to be wary of that. And it's just the same. Again, click analyze, and you'll be asked the question in a minute when it does the analysis. So it first chooses which aquifer you want to actually analyze, like so. I'll click the blank. It asks you about NAPL substitution. I've been through that already. And away you go, it's fitting the model, and there you go, it's plotted the results, and it's exactly equivalent basically as well. Cool. So that's we'll send you the slides afterwards, right? There's some screenshots of the things that I've demonstrated here already for you. Okay. Suffice to say that version 3.1 is now released, and you can get it on Claire website or the API website. On a longer term basis, we're interested to hear more about your experiences with well network optimization, like new well placements, well sampling schemes, etc. So if you have any feedback, let us know. A couple of issues I alluded to earlier, right? So ballooning is this the statistical anomaly where predictions can be high in area where there's no concentration data. Again, you haven't given the model enough resolution. As I said earlier, the best way to do is to up the modeling resolution. There's a paper here which also discusses it in more detail as well. Again, in terms of, I would encourage you to sort of check the model. This is using the spatiotemporal predictions plot just to make sure that the model you're demonstrating in the spatial plot is representative of the data you've collected. In terms of the Plum diagnostics, well, the major assumptions is we model spatiotemporal to do space and time. We don't model any heterogeneity in thickness, right? So we assume that the aquifer is homogeneous in depth, right? And that's why the model is done on an aquifer by aquifer basis, right? Because we don't model that change there. Also, there's an FAQ document on the API website, right? If you have any issues, use that as your reference and the user manual first before contacting myself, right? I think, a lot of the answers that a lot of the questions we previously asked have been answered in that text as well. There's a list of useful references here as well, and this is giving a goal mostly about the technical details, okay, but then, you know, we're hopefully going to get some use cases published in journals as well, right? If you look at the GWSDAT web-based website, you will see some examples of case studies, right? These are good, and I'd ask you to have a look at them, right? Because that really help give you examples on where GWSDAT is useful. And on that note, I will end it there and open up to questions, or more questions, if there are any indeed.
Thanks, Wayne. That was really good. Yeah, if anybody has any questions, you know, put your hand up and feel free to ask or type them in the chat. I've got one to kick off from me, if that's all right, Wayne.
Go ahead.
You mentioned at the start about units for the data that you're being imported. You can't have different units for the same determinant, is that right? So if you had historical data that say was in milligrams and then some that was in micrograms, you need to convert that yourself before you import it.
Correct.
And that's the same with NAPL and anything else.
Yes.
Elevations.
Needs to be consistent, you know, data input. I mean, what I'd say in general, you know, a lot of my time and effort is done in the kind of data inputting, but in reality, if we warehoused our data properly, then that shouldn't be an issue, right? And that's why we're eventually kind of looking for databases. Yeah, there is actually a GWSDAT report for some database systems as well. So some of the labs, for again, and the EarthSoft software, Equus database, the standard reports, right? And I think in reality, these data checks should all be done when you're putting the data into the database. And then therefore, when you get that data out of the database for GWSDAT, it should all have gone through the proper checks. In other words, we should centrally manage the data instead of just, you know, keeping the data on Excel spreadsheets, because it's more prone to a header, basically. I think there's lots of work to do in that space, basically.
Brilliant. Yeah, that all makes sense to me. I just wanted to double check before using the tool.
I'll send you the link to.
Well, Wayne, I've got a quick question.
Mm-hmm.
Will the software import AGS data, which is the standard format we get it in from the laboratories?
Oh, no is the answer to that one at the moment. But what we're working with some labs is for them to actually give you the data in GWSDAT format. Yeah, like the report, for example, I've just given you there.
Cool, thank you.
There's one, I've forgotten the name of the lab, I'm embarrassed to say, but it's very local. It's in Deeside in North Wales that they're based. So
That jets and sewers.
No, I'm not going to look up when I'm sharing screen.
Don't worry.
But yeah, you know, local, just kind of. You know. But again, you know, I think the secret here is there should be more of an effort, you know, to centrally manage the data, and the data check should be done there. And, you know, once it's managed in a certain format, you can just build standard reports that output it in any format that you like, right? I think that really is the key here.
Thanks, Wayne. I think Anton's just answered your question about the lab Jones element.
No.
Is that them? No?
No.
Right.
God. Oh, at ALS, is it ALS Global? Someone like that? I'll paste it in afterwards.
I reckon we can play
I don't
laboratory
want to keep
bingo.
scrolling my emails in front of everyone watching in. Yeah.
Yeah, no worries.
I think it's ALS Global.
Brilliant.
Hi, Wayne. I've got a question. It's Josh from Atkins. This is more kind of question based on the installation. I used GWSDAT recently on a site for the first time, and yeah, it was brilliant. I used the online tool, but was just trying to get the Excel add-in working. And obviously working for a company like Atkins, there's a lot of kind of loopholes you've got to jump through in terms of getting administrator rights and whatnot. We have like I'm not too familiar with R, but we have RStudio as a package in our kind of software that we're offered. Does it have to be this cran.r project that you kind of download? There was some issues.
So yeah, there's some confusion around this. So R is R, and what RStudio actually is basically a development environment for R. So you still need to install R if you're going to use RStudio, basically. Yeah.
Right. Okay.
But maybe, yeah. So it's basically a GUI for R is what RStudio is. So somewhere you've got R there, basically. Yeah.
Right.
If you have any issues getting it installed locally, then let me know. Right. You know, the instructions on the websites, you know, are geared up to hopefully help with most of the issues, right? So when you install R, for example, locally, you have to install it with admin rights, for example. It's that kind of pitfall. So give it a try, see where you come undone, and then get in touch. Yeah,
will do. Thanks, Wayne.
I think there's a question from Sam as well. Samantha.
Oh yes, hi. Could you explain the difference between the concentration threshold and the plume threshold?
Ooh, right. Okay. Good question. Can't not get me on the spot. Right. Let's see. Here's one I did earlier. So, oh God, let's get the simple example going. Let me just do the simple example out of it. So it was the concentration threshold and the plume threshold, right? Okay, let me just get this up and running. Okay, so the plume concentration threshold value, okay, is what you're used to delineate this plume here. Okay, so this uses a value of 10 in this example here, and you notice that there's something here in the options which says concentration values here. Got the plume ones there, and you've got this plume concentration. I didn't actually talk about it in the talk. The default is for the trend and threshold indicator matrix to basically look at the trend, right? But instead of the trend, you can look at a threshold value, right? And basically what it does is it asks the question is that data point above or below that threshold value, right? And you can see here that threshold value, I think the default is 500 here. If I come here, I should be able to, if I display the threshold value, okay, it's saying this is the value of 500. Is this below 500, above the 500, or above the 500? Yeah. So it's basically, instead of looking at trend, it's just looking at absolute values and asking whether it's below. Yeah, there's also a threshold statistical, and what this is doing is actually saying, is the upper 95% confidence interval for that trend fit below that threshold line as well? Yeah, hope that answers the question.
I think so. I guess what I'm thinking about is, would I, if I've got specific sites thresholds, I would be entering those as the concentration threshold and not as the plume diagnostic.
Yeah, yes, you would. And you do it here, right? You do it in options and you put them there, concentration thresholds there. Yeah.
Okay, thank you.
All right, cool. Okay, God, I'm all talked out now.
That was really good. Thanks a lot, Wayne. So I think we've just about run out of time for that one. But much appreciated, really interesting. I'm sure Wayne will be available for follow-up questions if people still want to talk about GWSDAT.
Feel free to email me if anyone has any questions on it.
Brilliant. And we've now got a little 10-minute break programmed in. So if people want to just take 10 minutes, grab a cup of tea, glass of water, then we'll start with the Ambisense presentations at 2:10. So yeah, thanks very much everybody for your attention so far, and we'll look forward to seeing you in 10 minutes time. Cheers. I think we're ready to kick off the afternoon session. So I'm going to hand you over to Tom and Rory from Ambisense, who are going to talk about, Ambilytics is the word that I have here. Yeah. Tom has a lot of experience working in academia, applying data science and machine learning to the design of new materials. Designed and implemented systems to automate the calculation of material properties from ab initio quantum mechanics, allowing the use of machine learning to techniques to be used to guide material discovery. So that all sounds great. I'm looking forward to understanding exactly what all that means. Rory works with him over at Ambisense, so I haven't got any more info, but I'll hand over to you guys and look forward to the afternoon. Thanks.
Yeah, thanks a lot. So Rory's going to start off with running through a quick introduction, and then I will take over and do a session and finish off with a bit of a practical run through. So over to you, Rory, if that's okay.
Lovely, thanks, Tom. Hi, everyone. I'm an account manager at Ambisense, and just to give you a bit of a flavour, a bit of context for what Tom's going to be talking about in his session, my job is here to run you through a few bits to show you what Ambisense are about, what our mission is, sort of who we work with, and how we help environmental consultants achieve their goals and sort of solve some complex geoenvironmental challenges, including data. So we'll just jump on and share my screen. I'm going to share sound as well because I've got a little video for you guys. Just jump on here. Go. Can you guys all see that? Yeah.
Yeah, all good. Thanks, Rory.
Lovely. Okay. So, so who are Ambisense? We are a technology company. We've been around since about 2013, 2014 now. And we love sort of complex challenges. We love environmental consultants coming to us with challenges. Maybe they need more data, or they have an issue where they've got lots of old inconclusive data from old school traditional methods of monitoring, maybe spot monitoring. And we love, consultants coming to us and saying, guys, we haven't got enough manpower. We haven't got the technical capability to get the high quality data that we need to provide sort of a multi-line of evidence report that they need to send off to the regulator to maybe assess a site or classify a site. So this comes in loads of different aspects of contaminated land and the infrastructure business. We started off, the business was actually coined out of the gas flux, the invention of the gas flux, which was the first ever device to record real-time gas concentrations and flow recordings. And then sort of as time went on, as well as the gas flux, we started integrating different devices into our remit that consultants can use in conjunction with gas data, such as water levels, real-time water quality data, real-time geotechnical vibrating wire piezometer data, and most recently we're getting involved in outdoor air quality, so sort of dust parameters, and indoor air quality as well. So the idea is, and then obviously most recently in the last few years we've been putting a lot of effort into Ambilytics, which Tom is going to go into later, and hopefully you guys can have a little look at and a go at. And the idea is to get as much data, disparate data, into that platform to enable you to make decisions quicker and sign off and send off your report to sort of the regulating body and look for trends and patterns, and maybe identify the way in which certain parameters, whether that's ground gas, water levels, or if it's weather data, which is obviously also introduced into the platform, whatever that data may be. Ambilytics' aim is to help you crunch the data quicker rather than using spreadsheets to analyze that data and look for maybe correlations between certain parameters. In a ground gas perspective, obviously the easiest way to look at this is dropping atmospheric pressure and gas flow rates and things like that. So the platform essentially allows you to cut through and analyze data a lot quicker than historical methods of doing that. So that's kind of an intro to Ambisense. If I move on to what I'm hoping to achieve and what Tom's hoping to achieve, in my little bit today, I want to raise awareness to you guys of the advantages of using that remote technology and the software in a contaminated land and infrastructure setting. Also explore with you guys, how we work collaboratively. So how, from the point of you having a complex site that maybe you're tendering for, or with an existing client where you have contaminated land, maybe it's on an old landfill, or an old chemical works, or you need more high quality data. How do we go from having the initial challenge all the way to then shaking hands and going, right, we've come up with a neat solution for the client, they're happy, and we've saved them X amount of money or saved X amount of time, and speeded up the program time of their project. Also, I want to give you a little overview of some of the sensors and the technologies that are available. In terms of IoT, when we're talking about IoT, this is Internet of Things. So this is devices that sit in field in situ and speak with the satellites and back into the cloud to give you the data in real time. So I'll show you the different devices that can be attached to these modems and give cloud-based recordings as well. And then we'll move on to, I'll let Tom take over and do a deeper dive into Ambilytics and show you some of the things that are happening there. Okay, so that's about it. If anyone else wants to ask any questions throughout, please feel free. I can't actually see the chat at the moment, but I'm sure if I fiddle around, I'll be able to find it. Or if you want to unmute your mic and just butt in, please do. So the first thing I want to talk about is from your point of view then as an environmental consultant, or geotechnical engineer, or if you're a bid estimator, if you're just sort of in the environmental consultancy business, this is how a lot of the big consultancies engage with us, and this is how they get the most out of their interactions with Ambisense. So I want to walk you through this. Quite often on some of the big projects, some of our main clients will come to us for a main example that I've got on the next slide, which is the Lower Thames crossing. How do we go? How do we get from A to B? How do we get from, wow, we've got loads of old school data here, we can't really make much sense of it, we need to prove that this site isn't as risky as we think it is. Maybe we're being told that the site is more risky than we actually think it is. So we want some high quality data to back that up and actually support our argument in our risk assessment. So you come to us, you come to myself or one of the commercial team in Ambisense with your challenge. We discuss it, we'd identify sort of what data needs to be found, how quickly and how many locations, and what exactly it is that you're hoping to achieve. Then at Ambisense, me or one of the commercial team would go back into the team, into our wealth of knowledge of experts and professionals, and discuss the challenge and bring it to the table, work out if it's something that we can use with existing hardware, some of the devices that I spoke about, in the gas, water, geotechnical area, identify if we have telemetry that's already available for that would work, or if maybe we need to actually uncover a more bespoke solution for some geotechnical devices that don't have modems attached to them yet. Then we come back to you we present the idea to you, we ask you what you think about it, get some feedback from you, maybe do a cost benefit analysis if we need to. Sometimes our clients like the idea of automating big portions of their large projects in contaminated land or infrastructure, but they're not convinced that doing it automated will actually save them money. Maybe doing it manual might actually save money. So what we do is, as free of charge in all of our pricing up our jobs, we do a cost benefit analysis, so that then when you're speaking to the client, you can compare the manual approach and compare the automated approach. We pick it all apart in terms of what would be needed there. So, day rates for engineers, sampling equipment, days on site doing the collections, etc., reporting, and then someone sat at a desk and actually analyzing that data in Excel, compared to using Ambilytics, where everything's automated and streamlined, and it's a case of logging in and just creating a graph. And we look at what that would cost, the cost would be to your business. You go away and present that to your client, and then on a good day, we sign the deal, and you guys move on and provide a neat solution for the client. So that's kind of our process. So we like to encourage, you guys as a collective to come to us with your sort of environmental monitoring or data issues. Maybe if you have historical data that's inconclusive, or if you feel like a lot of data is required to actually prove the hypothesis that you're trying to prove in your challenge. We encourage you guys to come to us, and we follow this process to try and come up with a neat solution for you guys to take to your client and win the business for you. So that's our process. In terms of the actual kit itself and what it does and where it can add value, there's no other better way really for me to do that than actually use one of our existing clients, Tony Windsor. Some of you may know him from Arcadis. He was the geo-environmental lead on Lower Thames Crossing, and used a collection of our remote hardware and Ambilytics to actually help with getting DCO approval on the geo-environmental aspect of that project. Obviously, it's a very complex project with lots of old landfills surrounding lots of the different areas of where the tunnel was going to be made. And there was a lot of investigation that needed to be done in terms of ground gas, groundwater, dissolved gases. So the guys opted to use Ambisense on this to try and basically get the data more speed lined and reduce the program time rather than someone doing that all manually. So I'm going to click on to Tony and let him talk to you for a couple of minutes, because he explains how they used Ambilytics and the devices quite well. Hopefully you'll be able to hear this. Actually, I've already got it open over here. Just let me know if you can't hear it, but I'm pretty sure I've shared sound, so you should be able to hear him. Here we go.
From a ground gas point of view, we use the continuous remote monitoring. So this was the we used Ambisense devices here, coupled with dissolved gas probes and continuous volatile monitoring as well, and flow rates. The reason why we were so keen to use these devices is so that we could, because in the landfill areas we have this huge variability in terms of the peat layers. And then mixing that with the tidal variations that we're getting because we're so close to the Thames, and then obviously the very significant ranges in gas, and then depending upon whether it's going to be the north portal for the tunnel itself, or any buildings above and around, whether temporarily or permanently, we really needed to understand really much better than we could do with the sort of typical point monitoring you might do over a period of weeks or on a monthly basis, really what was going on, because we didn't want to miss that data. And so that chart at the top there certainly shows you the variation we can get with the tidal influence, and then these other matrices here, what they're doing is they help focus our attention into the key drivers. So the number of parameters there, and then how they link together, and how, for example, the atmospheric pressure causes an increase in methane, or how the water level causes an increase in methane. It's really to focus in on what the parameters are that matter and what they don't, so that we can then look further into those and make some better decisions, better informed decisions on what needs to be done in terms of the protection measures for any features going forward.
Lovely. Okay, so that was Tony, obviously talking about Lower Thames Crossing. Thank you for listening to that part. So just going into some of the advantages that Tony mentioned there and just highlighting some of them. What Tony said there was basically they might miss quite a lot of the critical parameters in terms of what was affecting what in the gas regime, and also tidal influences. So this here enabled them to sort of identify the critical parameters 5 times faster to proactively intervene with any risk on the project by using this technology. Also, a lot of the area on the Lower Thames Crossing was obviously farmers' land, and landowners weren't exactly happy with repeated visits from site engineers to do manual monitoring. So by using automated systems which are only put into the field once and then left there, and stream data into the cloud, there was an 85% reduction in cost and disturbance to landowners in those areas. Also, by using the technology, it minimized the risk of expensive project delays. So if there was a delay due to a data shortage, this would in turn cost the project in the thousands or more, because if a project's obviously at a standstill, then they have to pay for the contractors and the equipment and diggers and whatever was on site longer, because they're waiting for, there's a hold up on data. So getting everything streamlined, especially in these big infrastructure projects, is priceless in the long run, because it means that your program time shortened and your overall costs of the project are minimized as well. So these guys as well, by using this technology in this sort of setting where it's very important, if you're tendering with a company that uses remote technology like Ambisense, gives you that edge on people that are maybe doing this in a manual way, and will give you the ability to win more business for using the innovative technology. We mentioned there about honing in on critical parameters. Tony mentioned not just site contextual data from devices, but also weather data that might have an impact on risk. And also adding to the sustainability of the company's carbon footprint. So by using automated technology in the field, you're reducing the amount of times that engineers are driving around to various remote locations and travel. Obviously, you're only using one system in one place. So overall, you're reducing the carbon footprint of the project. Now, obviously, the big consultancy companies, this is a big thing at the moment going into sort of 2022. So some big engagement there, and obviously it helps with the overall PR aspect of the project if you're managing to keep that down. So that's some of the benefits of utilizing remote technology on infrastructure projects. I'm going to move on to a contaminated land focused project now. So in terms of contaminated land, quite often using the real-time gas monitoring can come in handy. Like I mentioned earlier, when you're maybe being told that you have a problem from some anomalous data or inconclusive ground gas data, but you're fairly convinced from conceptual site model and from your general understanding of the site that maybe the site should be classified in a lower risk setting. And obviously the implications on over engineering on that site will be reduced. So the cost to the end client comes down again. So this is where automated gas monitoring can come in handy. We had a big project with Arup on the Eastern Quarry, and EPG, and Steve Wilson got involved on this one as well. There was a lot of historical data using gas clams and spot monitoring over the years, and this was ensured by the NHBC. Now, we in the end managed to get the site from amber down to green by sort of a small investment of around about £40,000 on automated gas monitoring to get high quality data. Now, the implication of getting that down to green classification meant that the client didn't need to spend massive amount of money on gas protection measures over this massive residential development. So they estimated that they saved about £1 million in cost on gas protection measures, and that's an accurate figure because of how big the project was. Using this portion of high quality data, they were able to actually change the overall classification of the site dramatically, and therefore the gas protection regime and measures required were reduced as well, and the cost of the project. So in projects like this, it's a big win, big financial saver. Amy Juden, who was at Arup at the time there, took a bit of a risk on this and went with the bold approach. Obviously, for years, guys have been using manual monitoring, but they were convinced that it was being, being over conservative on this project. So they took the risk. It was quite a bold thing to do in the industry at the time. This project's been nominated for a Brownfield Briefing Award. And in the end, it paid off. And they managed to obviously save in the region of £1 million. And this is only one parcel of land out of 12. So the savings, could double, triple, or even more when we start looking at the other parcels of land for this residential development, where the data found from Steve and Amy and Ambilytics can be applied to those portions of land as well. If anyone wants to view this case study in more detail, go over the technical details of it, we can send that out. I think we'll be sending the deck out after as well, and you're welcome to have a little look at that if you want to look at it in more technical detail. But overall, in terms of using this sort of technology in contaminated land, what are the benefits and advantages of doing that as a consultant? Well, firstly, you'll get a better quality of data. So you're getting data every hour in sort of a continuous format rather than sporadic spot monitoring at random times. So taking a flow sample at a random time, you're only getting a representation of what was happening at that point in time. And you could miss a key point in the weather regime where the gas regime was altered, or you could end up getting a scenario which is worst case than what the site actually is, and overspending on the site. You hear Steve Wilson talk a lot about the industry being quite over conservative. This is one way to not do that and to actually save money and do your gas protection measures correctly. Also, a massive reduction in program time for your client. Obviously, in this instant, time is money for your developer clients. And obviously, if they can get on site and build their buildings and start selling buildings quicker by using automated technology, then the return on investment for them is much quicker. They're happy, you're happy, we're happy, and everyone's happy. So obviously, we spoke about that point there in terms of more robust data and money saving. Reduction in project delivery costs in some cases, obviously not all. We're not saying the automated approach is fit for all sites. Some smaller sites where maybe there's not as much of a risk and you just need some spot data, then manual monitoring might be the approach. And some of these more complex sites, you're going to get a reduction in project delivery costs from manpower on site, someone actually analysing that data and looking for trends in Excel. And the travel expenses, someone driving around to these remote locations as well, and hotel costs, etc., compared to just a box in the ground and an Ambilytics license. And also health and safety aspects as well. So reducing the amount of time spent on site, using a system instead is going to reduce the amount of risk that you have to your business from people being on site. So that's that. We do, as I discussed earlier in the presentation, when you're sort of assessing a geoenvironmental challenge, something that our clients that have been really keen to use is a cost-benefit analysis. Now, I spoke about this earlier. This is the opportunity to actually compare the manual approach to the automated approach on a project-by-project basis, so that you can see what the best option is for you to do in black and white. Now, I've got an example here of a project that we did in Wales. This is a contaminated land site, and they were going to opt to do things manually. On the left here, obviously including manual monitoring, instrumentation cost and hire and installation of that kit, monitoring visits, recovering the data, and then someone processing the data and putting that into a report. And then we compared it to the Ambisense Ambilytics approach. And on this occasion, the automated approach gave them a saving of around about £8,000 and a reduction in program delivery time for this part of the GI of 4 months. So in some aspects, there's a lot of time saving and money to be made, and we do these free of charge as well. If you want to do a cost benefit analysis on your project, we can do that. So that's just a quick example there. In terms of the hardware then, what actually goes in the ground? So from more of a technical aspect, this is the gas flux that I spoke about. This is our signature product that we sort of bring to market. Does your continuous bulk gases, and also an option for vapor as well, so total VOCs, and obviously the continuous flow measurements as well. All telemetry, all based in the cloud, can either be used with a lithium-ion battery or solar panels for longer continuous monitoring, maybe for seasonal variations, or construction-based monitoring, where maybe you need to understand differences in data pre, during, and post-construction on sites to understand how you're affecting the ground when you're doing things as well. And then also we integrate other devices as well. So as time has gone on, we've integrated water level loggers, dissolved methane loggers, dissolved gas probes, vibrating wire piezometers, water quality probes, etc. And these can all be installed in the same borehole, so you have relevant data coming from the same borehole as well. This is a bit of a diagram, what it looks like in the ground. This is actually a photo taken from the Lower Thames crossing. So just a bit of an idea of what it looks like on site. The system's obviously housed in these security headworks to give security, and we'll just stream you data real time for whatever you require. These fit into sort of standard borehole standpipes that you'll find on a standard site, and that's about it from me. So unless anyone has any questions on that part of the that part of Ambisense, I hope that kind of explains what we're about and what we do, and how we add value, or how we aim to add value to you guys as the consultants, and hopefully that gives you a bit of an understanding of maybe how you would you know, tackle some of these more complex sites, and give you the confidence to get in touch and explore ideas and solutions for certain sites that you might have. Obviously, all of that is all well and good, but maybe to understand it more, you need to have a little look at the Ambilytics side of things, or even better, get your teeth stuck into a project and actually use Ambilytics, which Tom is going to show you, so that you can start to understand and use it in anger, which is a lot of what our clients like to do, and that's how they really learn how to use this stuff and find the most value from it. For instance, Steve Wilson is still finding out new ways that he can tackle some of his complex projects using Ambilytics, and comes to us with a new feature that he's found, or a new way of you know, uncovering or solving it, one of his challenges. So that's about it from me. Any questions, or are we happy to move on to the software practical side of things?
The questions?
Yes, I've got a question. How does maintenance or calibration of the equipment fit into the remote assessment using automatic devices?
So in terms of if you're doing sort of a longer term monitoring, if you needed to maintain it over a longer period of time, do you mean? Or? Yeah, so we would, as a standard, we would calibrate our units every 6 months and do a sensor check and make sure everything's working well. So if you were doing a long-term duration, we'd come and swap the units over. We'd come with a fresh unit, put it on, take away your one that was on, recalibrate it, check everything was working correctly, and do it that way. Obviously, before every deployment, units are tested and calibrated as well. But if you're doing a longer term duration, we'd come in and swap and every 6 months and make sure everything was working all right. Other maintenance as well, you will need to change the lithium-ion battery. Usually it will last about 4 to 6 weeks if you're not using solar panels. So we just factor in maybe half a day to visit and change the batteries every 4 to 6 weeks if you were doing a longer term deployment. Quite often our clients only need about 4 to 6 weeks of data if they're doing a standard sort of contam job, just for continuous gas and flow data. But obviously, yeah, if you were doing longer term hire, you would sort of build that in into your job.
Thanks, that answers my question. Thanks.
Lovely.
Any more questions, or are we happy to move on? I think it all looks good if you want to crack on, Tom.
Okay.
All right, thanks, guys.
There we go. Can you see my screen? Take that as a yes.
Yeah, all good. Thank you.
Okay, so what I want to do is kind of move on from what Rory was saying. So as you heard, so I've got quite a large background in data analytics, and moved over to look at this industry a couple of years ago. And after working in it for a little bit, it's very, very clear that one of the main sticking points for where we are is the point that Wayne finished on, is the custodity of data. So how we get that data in, how you can sort all that out, make sure that it's clean data, and store that data. So that's very much what I'm focusing this presentation on, is kind of the tools that we've put together to try and help you get data into the system. So as you know, so the incumbent solution is very much a manual monitoring solution. So you go to the site, you use a handheld meter, write it down maybe in a clipboard, and it ends up in Excel, which then manually gets put in a report, and more often than not gets put on a shelf for someone to read at a later date. So this is quite a slow process. You get very infrequent data. It's very expensive. There's less data, so the pure frequency with which you can visit the site is lower. And because it's less expensive, you can, because it's more expensive, you can't visit as many sites. You've got the potential of human error, and there's more of a focus on kind of pre-assessment. So you put it in a report and stick it on a shelf rather than continual monitoring. By having an option of continual monitoring for regulatory issues, this keeps the regulator happy. So if you're offering a continual monitoring solution going through the project, you can offer kind of lower bounds on that solution going through, because the margins just don't have to be as high. So this is where kind of Industry 4.0 comes in. So IoT, as Rory mentioned. So IoT is it's banded around a lot, but essentially it's very it's a relatively simple concept. So you have a device, you have connectivity, and you're pushing the data up into the cloud to analyze with various analytical methods. There's a couple of stumbling blocks for implementing this for the industry. So the first stumbling point is connectivity. So a lot of the devices that are being used in the field, these have no connectivity available to them. So as Rory mentioned, we've got a set of different solutions to push these up. We've also got the ability to connect up various different modems to the devices to actually get the data into the cloud, so that we can do more advanced analytics on it and get the most value out of that data that we can. So Rory went into that in depth, so I'm not going to band on about that. The second sticking point is when you've actually transmitted that data, the data's in all sorts of different formats. So we were mentioning AGS before. So you've got AGS formats coming from the laboratories. Can you read that in? Or no, we can't read that in. We have to. There's a lot of talking about kind of how to get that in. So this is going to be largely where we are with this presentation, and what we're going to look at in this presentation, how this can be addressed, or at least the issues associated with it minimized. So connectivity wise, there's a few different standards, and then these can talk to various different API standards, so interface standards. But what it comes down to in the end is each of those interface standards can accept various different formats of data. So if you take FTP, for example, FTP is sending a text file or a file of some form across the network. So the protocol and the API know that this is an FTP file, but the file can be as different from a Word document to a CSV file. So how do you actually deal with that? So although the data can arrive in the cloud, how can you process that into some meaningful form to actually do your analysis on? So what I want to do is kind of run a quick practical session on the Ambilytics software to kind of show you some of the tools that we've got, and try and minimize some of the issues with getting data online. So to start off with, if you go to dashboard.ambisense.net and log in with these credentials here, and we'll start getting going. It's quite hard doing this interactively because I have no feedback when people have done things. So, so if someone can pipe up that you've managed to do it, or there's an issue, otherwise I will move on to the next bit.
I've managed to get myself in now, Tom. So.
Perfect. Thank you very much. So I'm taking that most people have probably got in. Pipe up if you still need this slide. Okay, so when you log in, you should see a page that looks like this. So within this page, essentially, the project is the space. So I've got an organization, I've got a space in that project, and that space contains the information associated with the project. So it's relatively blank at the moment, so I've left it as a pretty blank canvas for you guys to play with. So I'm going to the next slide now, so if anyone wants this one, shout up. So once you're in, if you click on things on the left-hand side, so that's this one I've highlighted here with the arrow. So you can see I've got no devices. What I've done is I've set up a set of arbitrary test devices. So these are virtual devices. They don't have anything physical connected to them, but these store the information that's going to be pushed to these particular devices. So if you click on the Things tab, you should see this this bottom one appear on your screen. Okay, so if you choose a device, so let's choose test 10, for example. Here we have various data associated with that particular device. So if you flick through, you'll see that it's quite blank. I haven't added any data associated with this device. It is really just a placeholder for putting data in. But when we create the device, what we do is that device has credentials associated with it. So you can get those credentials by going to settings at the top and then API keys. So remember how to get to those, because we'll be using those in a second for you to push data into this system. Okay, so next, what we're going to do is we're going to simulate a device. So what we see in Ambisense is there's a lot of devices that push data over FTP. So I'm going to use FTP as an example for this. This is not a limitation, and it's not the only thing that can be done, but this is one solution that we can put together and we can run as a tutorial. So you can effectively simulate a device and push data directly in via FTP. So to do this, what we're going to use is we're going to use a local FTP client on your computer. So if you download something like WinSCP, so I've done the examples for WinSCP. It doesn't really matter what FTP client you use, as long as you're happy using it, but all my slides are going to be based on WinSCP. So if you download that and launch it, you'll see a window that looks very much like this. Any issues so far?
I've managed to get it installed and it seems to be okay.
Okay.
Bassith has asked, is this FTP only for Windows?
No, FTP is general. You can use it in Mac, Linux. It's a lot more straightforward in Linux. FTP is a general file transfer protocol. What are you trying to use?
So I'm using Mac and I'm trying to download this client WinSCP. But what I'm getting is an .exe file. I don't find one for the Mac.
It should be. let me find you a Mac capable client. There should be well, there will be loads. CyberDuck, Fetch, Expand Drive. So there's a good few alternative clients there that you can use.
Okay, I'll try. Thank you.
Okay. But yeah, so it's actually quite hard work doing this from doing this on the computer. It's a lot easier from an IoT device. So this is a very standard protocol to use. So first of all, the first box, we have to choose the protocol. So WinSCP supports a few different protocols, so we're just going to use FTP. In the second box down, we put the host address. So this is the server that's hosting the data. So this is where we're going to push the data to. And then the third box. So these are the credentials from a couple of slides back. So if I go back, I'm going to go back a couple of slides. So that's these credentials in your API key. So the ID is your username and the secret key is your password. And these are specific to the device. So this tells, so when we send data to the FTP server, this tells it which device to put that data in. So once you've entered those bits, if you press login, you should see a screen that looks very much like this. So you've got your files on the left-hand side, and you've got a relatively blank directory on the right-hand side. So the one on the right-hand side is the remote location that you just logged into.
Okay, I think I'm just about keeping up, Tom. If anybody's not keeping up, please just say in the chat box.
Yeah, let me know if Matt's too speedy there, and we'll slow down. But okay, so on the right-hand side, what we're going to do is we're just going to make a text file and send data to the system by putting a text file in there. So as soon as we save a text file to that directory, that will automatically be processed by the system. So if you right-click in that right-hand box, click New and click File, and this will create a text file. You can call the file whatever you want, something.csv. The system doesn't read the actual file name; it just looks for files with a .csv extension. So once you've done that, so in the file, what we're going to assume is that this is a CSV file. So this is comma separated values. So the first line is going to be your keys. You can add as many keys as you want. So it might be temperature, pressure, humidity, and then below that you have columns of data. So you have the same number of headers as you do columns of data. So here I've just got an example with 2, so temperature and pressure. Temperature I've set to 25 and pressure I've set to 1000.
Tom, would it be possible to put the host name in the chat box just so people have it there?
Yeah, sure.
Thank you.
Go back up again. There we go.
Amazing, thank you.
Okay. So you can pick any of the devices. I've put 10 devices there. If you pick one, so you're all going to be using them and kind of interchanging. So we're going to get all sorts of data in there, but that's fine. But if you want one of your own, if you pick one that no one else has used, you'll get your own little setup there. Okay, so we make a text file and we save that text file off. That file will get processed by the system. So to see that it's been processed by the system on the device, so we click things and then select your device. And then if you click events, you can see that data arriving on the system. So in this case, the data is shown on the right-hand side.
Sorry, Tom, a few messages coming into the chat box. If you can take a quick look at those.
Okay.
Think about the username and password. And someone's having a bit of a problem getting in, access denied.
Access denied. Okay, so the username and password. So I'll do that one first. So here, your username and password that you're entering in here, these are from the credentials for the device. So if I go back up to the device itself, let me I'll do it on a live terminal. I go to my space, I go to things, I choose a device, go to settings, API keys. So these are the username and password for sending data to that particular device. So Alice, you're getting access denied. Are you still getting access denied? So these are quite abstract keys and usernames, so it's probably best to cut and paste them. Okay, Gemma's got it now.
Feel free to unmute Alice and let us know how you're getting on.
Okay, Alice has got it. Thanks. That's good. Right. So now, so for those that have just logged on, so what we're doing is we're just right-clicking in here, creating a new text file. And in that text file, you're making up a CSV file. It can be very brief like this. So you could just do temperature and then a number on the next line, and that'll be passed. So when you save that file, the system will automatically identify that file and it will process that file. So all it's doing is it's assuming that it's a CSV file. It will process that file, and in this case, it's for me. I've put pressure and temperature as my two keys, and it's extracting those keys for my device.
Sorry, how am I looking at this events tab? Where do I find this?
Okay. Go back to the live one. So if you go to things, choose one of your things, you've got an events tab at the top. So if I choose that events tab, I can see so all the events. So in this case, we've got both unprocessed and processed events. So the unprocessed, this is essentially the raw data that's coming into the system. So I can see there's some data coming in here. So someone's got temperature/pressure of 25/T1000. So I think the CSV format needs to change a little bit there. So your CSV format needs to be, go back on the slides. Something like this. So it's comma separated. So it's not slashes, these are commas. So if you go to, you select your device and then choose events, you should see your events coming in. So if you've chosen a distinctive name, you will see the name coming up as opposed to everyone else's names coming up. So data comes in this unprocessed form. So it's kind of an FTP upload event. So everything on here is an event. So events are they're stored on the system. They never disappear. So anytime that we touch the data or we do an action on that data, we've got a record of it. So you've got full traceability of what actually happens with this. So this data, as soon as it arrives on the system, it's processed out. So here we have somebody that's sending a single temperature/T pressure is your key, and then your value is 25 for that key. So I'm not sure whether you wanted that format, but you can see here that that's been processed out as temperature, pressure, and the data associated with that is 25. We've got other people here, so there's got quite a few events with data coming in on here. So someone's got something that's split out into temperature and pressure, so that's gone through fine. Yeah, so I think that's almost identical to what I had. And that's processed. So the next step, so now that data is in the system, it actually understands what that data is. So effectively, the last step in the stage of processing that data is kind of how that data is interpreted and how you interpret that data structure that's been pushed to the system. So here we've got a very simplistic case and we've assumed CSV. This could be AGS, this could be a lot more complex forms, but that data has to be understood by the system. You have to understand what the key value pairs are, that it's in the correct units, and before we can actually move on too much, and that we've got to and we actually understand what's going on with that data. So the next step is, once we've done that, is we can then start plotting the data. So if we go back to things and then select the device that you sent the data to, you can now add a widget. So we've got various widgets available. Probably the most useful for you is something like a line chart. So if you add a widget, select line chart, call it whatever you want. Ooh, sorry. The process data, this has been split out into your key values. So one processed event would have one key and one value associated with it. So although I sent a file with temperature and pressure, so the raw data going in is going to have temperature and pressure. I process that out and I split that into two different events so that the processed data has a key temperature and a key pressure. So here, if I choose processed event and temperature, then I can create a plot that looks like this. So I'm going back to the live view. So I go in the top one. Oh, we've got some new widgets appearing. Yeah, not a huge amount of data appearing just yet. So I take it that people are struggling a little bit with sending data. Is that right?
Mine just appears to be loading for rather a long time. So.
Which bit? The widget?
Yeah, I've just got a little orange spiral going on in the middle of my screen.
Hit F5 and reset it. Let's see if that clears it.
No, still doing it.
So,
I have created the widget. It's just that nothing's come up yet, but then I probably missed something earlier on that's making it a bit not work. I'll try adding another one.
Yeah, add another widget. So I'm just going to spin up WinSCP. So I'm going to go back to get the credentials. Oh, lots of files appearing on there. There we go. So I've got a live WinSCP and so I've made myself a text file called tom.csv. I'm going to give myself a key. I'm going to call it Tom, so I know what it is. And I'm going to give it a value of 20. So if I save that, I can see on the left-hand side, it tells me I've got a new event. Lots of new events. If I go to processed, refresh it.
In terms of how these are logged for date and time, Tom, is it just that they're literally it's at the point you upload the data is when it gets sort of catalogued temporarily?
So at the moment, so yes, so I've set it up so that it's taking this timestamp. So this is the uploaded timestamp for this particular device. This isn't hard coded. So what we've got on the system is you've got a very rough parser for the CSV, and then you've got a relatively light JavaScript on top, which you can which clients can actually change how this is processed. So if I go up to the device level, so I'll show you a little bit of, so we have kind of concepts of products. So here, what I've got is we're using a CSV product. So that CSV product has a very simple JavaScript parser in it. So it's a few lines here. But what this is doing is this is taking this is telling it to take the uploaded time as the timestamp. You can extract that time instead from the file that's uploaded. So we would typically do this, but this is something that's now really it's not a development task to add a new device type to the system, because you've got this relatively light parser to fine tune how you're dealing with the data when it arrives. So here, I'm just putting the key value pairs into that particular file into a processed event, and it's taking the current timestamp.
Okay, thanks. So you'd have different products in terms of different file types.
I'll say a little bit about kind of about inheritance. So I'm making you do a lot of work here. This is the core of what you would do if I've got a product and I want to get it online. How on earth can I get this thing online? That's very much what I'm running through with the tutorial. Once that product's online, once you understand it, you can inherit the properties from it. So what you would do is you develop a product. The pipeline for processing the data is inherited. So if I make a device of a certain product type, these scripts actually belong to that product type. So as soon as I spin up a device, these get inherited and used automatically. The same as the views that you're using. So I can put various settings, so I can save that this is a piezometer, this is version X of something or other. I've got various metadata I can attach to this product, which I can recall programmatically. So in the scripting that we've got on top of this, I can actually pull these values out. So this might well be calibration values, but all of these are available directly to the client, so you can see exactly what's going on. So it's just a case of picking through kind of the scripts that are running and the metadata associated with it. So it's not that when you upload a generic file, it gets processed and then you get the data. You have the full audit trail of everything that's going on with that data, so you can actually go back through, see what's actually make sure that data is being treated correctly and everything's being applied to it. So what happens more often than not is data needs some form of calibration. There's going to be a calibration date associated with it, and just making sure that calibration is good and valid and in date. That can all be stored alongside the product, so we can see that the data that we're getting here is good. So on the automation side, so there's a lot of inheritance that goes on. So these devices are created on so you create a product, you create a device of a product type. The visualizations and the processing is then inherited. So although I'm making you work very hard here to set up these things manually, because this is what you would have to do if you're given a device that's sending a file of a certain form. This can either be done by us internally, or this would only be done as soon as you want a new product set up on the system. So as someone's found out, so someone's having a good look around, you can make your own space. So spaces are essentially, think of them as projects, and within that that space, you can control who has access to that space. So this can be your own space. It can be, you can share it with whomever you choose. So as you're all logged in with one account, I should be able to go in. So in here, you've got various, you can create your new devices. So if you go add a device, I've got a device type, which is the CSV parser. So that creates me a device called test with all the bits associated with that CSV parser device type. So how are we getting on with sending data? Let's have a look at the FTP server and see. I've got a few visualizations coming. That one is stuck. It doesn't have an event name in it. So when you send the data, so here, what the initial packet is sent as an FTP event that is then split out into events which are named with the key of your key value. So in this case, my event would be called Tom. In your case, it's probably going to be called something very different. So what you have to do is put this event name in. So that's why the cog is still spinning on that one. So here, yeah, okay. So here there's an event temperature and there's an event pressure that we're trying to pick up the temperature and pressure from for that particular device. So I don't see much data arriving. I'm going to move to one of the other devices so that we're not all using the same one. So no one's used this one yet, so I'm going to create a new file. Okay, so I've created a file. I've got a key of X and the value of 10. I can see that I've got an event. Should have sent the event. Arrive in a minute. And while, which device was this? Not that one.
In terms of the processed versus unprocessed data, is that something that's part of the product as well?
Yes. So what we have to do is, so first of all, the data comes in a relatively rough form. So we go to kind of some of the events. So this is kind of all the data and metadata associated with this particular event. So it tells me that this data has arrived via FTP, and then here this is the data actually itself. So we want to differentiate this from what we present to in the final bit. So it's rarely the case that the raw data that comes in is what you want to present. So we differentiate between the unprocessed and the processed events. So this is the raw data arriving. We can then run some stream analytics, which is that little bit of JavaScript I showed you beforehand, which converts that into a processed form. So in my case, I've done it very simply. All I do is I just extract these key values into individual events. So here, this temperature event is going to be processed into the temperature event named temperature, so that then it's available for plotting. We can do more complex things there. So you can add a calibration. You can use the state variables. So if we create a calibration value in here, we can save that off. That's available to the code, and I can go, right, so I want this device to be calibrated with an offset of 10, and I can automatically apply that calibration. So this is why the two are differentiated from the raw data coming in to what you actually want to look at and view later on. But you still want that audit trail to be able to understand what calibration's been applied, why that particular data is looking as it is.
Got it. Thanks very much.
Okay. There we go. Right. So there's my FTP events. So I'm on test 1. I've been sending events with this test CSV, and I can see those events arriving. So they're giving me an X of 10 in the unprocessed. And if I go to the processed, I can see that this event has been extracted with an X. So then if I go back to overview, I can add a widget, a line chart, called X, processed, my event name. So this is a processed event, and the unprocessed data was converted into a processed event with name X. So my processed event here is X, past hour to now. Hopefully I can create a widget. So there's my widget. I've got one point, it's got 10 on it. Send some more data. Process it. Okay, so this is my data coming in. So I can keep changing this file, saving it off. It'll get processed and appear as a plot in the system. So this is a very simple example. So I'm only sending one data point at a time. So I can continue down. And add extra data points. I can add more data. So in this case, each of these are going to be passed out into individual events. I can either add them to here, or I can spin up separate charts for them. So what we're trying to do is create a very customizable interface, which gets around the last step of the process of putting data in. So if we sort out the telemetry of getting a device in, we provide a light environment which is very customizable for getting data into the system. And then once it's in the system, we provide various outputs. So for example, we provide AGS output, CSV output. You can loop over. So once you've made these dashboards, you can loop. So the dashboard can be made on the product level. And then for each product, each device that you spin up of an individual product, you can you can download all the data associated with it as a PDF. So this is effectively a report generation system. So you can create your own visualizations that you want to show and download them, and it automates the loop over the devices so that you're able to create reports. So how are you getting on with plotting a CSV file? Does anyone manage it? I'm going to have a look around and see what's going on. Aha, we've got some data arriving. That's good. Right. So whoever spun up Big Data Workshop is doing really well. Example 10 is doing well. So there's all sorts of data arriving here. Ooh. So it looks like some people are managing it. Is anyone struggling that needs help?
Was everything connected to test 10? Because I have a feeling I was connected to test 9, which is probably why I can't see any of mine coming up on your screen.
Let's go and test 9 and see what's going on. Oh, there's a whole load of people in
test 9.
nine.
That's probably all me. Okay, fine. Cool, thank you. It was just to check it was actually working.
Oh yeah, no, there's some people in test 9. Okay, so we've got pressure, rainfall and temperature arriving in here. That's good. So
and can you delete widgets? Sorry.
Yeah. You just go in, edit the widget, and there's a delete widget at the bottom.
Okay, thank you.
If you want to, okay, so we've got some annotations in here. What you can do is you can annotate the values. So say you have a threshold that you don't want to exceed. You can put that you can mark that threshold on the chart. You can save the value of that threshold in settings. So if you go up into settings and state, I might have a threshold I don't want to exceed. That value is then programmatically available, and actually on the plot itself, I can access that. I go to one of the plots. Where's the one that we put that someone started using these? Yeah, so here in the value, you can programmatically access that that bit of data.
Could you use the states to sort of set up bounding conditions for, say, anomalous data, for example,
could indeed,
if you're
yes.
measuring pressure and it's, you know, it's a 1 or something?
Yeah, no, it's whatever you would like to store in that. So essentially, the states are metadata that you that you want to store associated with the device. So here, you're free to put whatever information that you want in the state, also the location as well. So you can save a location for your device. So we put this here. So you can save the location. There's various general information associated with it, but the state is essentially, it's free-form metadata that you can access. And you can save bounding conditions. And so I was just digging up an example to show you how to access that programmatically in the graph. So if I have a state limit there, if I go back out to device 9 again, so I want to add an annotation. So I choose what axis I want to plot it on. So I'm going to plot it on water, label. So this is how I'm accessing that that particular state variable. So there's various programmatic options that you can automate the process here. So these aren't static pictures. We can save data associated with a particular device.
Hang on 2 seconds. Just turn this off. Hang on.
You okay, Wayne?
Yeah, sorry guys. Yeah, sorry about that. Someone's just called me. I'm going to drop out now, but thank you very much. Very good. Thanks.
Okay. See you later, Wayne.
Thanks, Wayne.
Yeah, so this is the limit line that I've just put on. And if I go into settings and I change my state, 20, save changes, I go back to the device. So that now appears at 20. So this is it's a soft-coded way of putting limits on. So if you've got a threshold that you don't want to exceed, so first of all, you've got access to that threshold programmatically. You've got access to that data via the API. So it might well be that you have a system, you can dynamically change that in what you're showing. You can connect that up to the device and show that. So you're able to automate a lot of the process that you're doing here. So are people still playing with the software a little bit there?
I have been, but if there's other things to cover, Tom, I'm sure we could move on. Yeah.
No, I tried to keep it as light as possible. So so very much the what we wanted to do kind of at the covered all that. It's very much getting you going and kind of showing you the basics of what can be done. But the key is really that flexibility. So you've got devices that connect up, but then the sticking point is always going to be, right, so I might have the data in a certain form. How on earth do I get that into a form that can be plotted? How do I automate that process to gather all that data together? So these are the basic tools to actually start putting that data together. So as Wayne mentioned, you've got a lot of issues with just getting the data into the system, and probably 90% of the work before you do the analytics is going to be just sorting out the data, getting the data set together. And then once that data set's together, the analytics is going to be the 10% of the work on top of that data set generation. So for those that have managed it, congratulations, you've simulated sending data to the system. So that's very much the first section. So that's the IoT device, how you connect that up, how you get the data in the cloud. And now that's the bit before the analytics, and that's where I'm going to actually stop. Okay, thank you very much.
Thanks, Tom. I mean, we have still got a bit more time.
We've got a few minutes left. If people have any questions about the platform or want to know how to do various different bits in there, I'm happy to work through that with you.
There's something that I was looking at when I was playing around with it, Tom, is trying to upload from 2 different files. So the FTP, so I had a test and test 1. Yep. But the test 1 didn't seem to be pulling in the temperature, pressure information into my widget.
It should do. It should be okay. So you can dump as many files as we want in here. And it processes them so interactively. So there is a few second lag for processing them. What you can do is, if you go to your things, choose a device. So you can go to debugger, and this will sit there listening until someone sends a data packet to it, and then there'll be some debug information as to what's gone on, why has that not managed to be passed correctly. So you can pick a little bit into why that's not working correctly. So I'm going to go back out to my device that I'm playing with, go to the debugger, new file. Okay, so I can see that that's arrived. I can dig into that event, so I can see, right, so first of all, it got a name of Y and data. So this is the processed one. So the unprocessed one, I can see the event arrived. I can see the how it passed out that data. And then for the processed one it made from it, it extracted name and date data correctly for that particular one. So the debugging tool is quite useful in setting this up. So we want to try, so what device are you in?
Yeah, I'm in test 9. I've worked it out. Yeah, I had my date range set wrong at the top, so it wasn't pulling in data beyond half an hour ago. So I think I've got it.
So from some feedback from everyone else. So you're all starting on your IoT and big data journey. What tools do you need to help you on your way?
You can add them in the chat box, or feel free to just unmute and just say them, whatever anyone thinks. Looks like maybe you've provided them with all the tools, Tom, judging by the chat box.
Yeah, no, okay. So
well, everyone can just continue adding anything in there if they think about anything. Thank you, Tom. That was a really excellent demonstration.
Okay, thank you.
Yeah, thanks, Tom. It's really good. Sorry if I asked too many questions there.
No. The virtual lectures are even less interactive than the real face-to-face ones. So it's an issue with face-to-face lectures. It's harder, even harder still with virtual ones.
Absolutely. Okay, I think everybody's deep in tinkering around in the dashboard there. So I'm sure Tom.
We'll leave it up. You can tinker to your heart's content. You will have the credentials to log in. Have a good tinker and see what you think. I'm happy to hear feedback on the bits that you would like in there, or if you want to add anything, let me know.
Fantastic. Thanks very much, Tom. Really appreciate that. And yeah, really interesting. Really interesting. A lot to get your head around, I think. So, yeah, it's good. It's great. So I think if everybody's happy, we'll move on slightly earlier to the drone presentation. If Jonathan's there with us, then we can crack on.
Yeah, that's no problem.
Right. So just a quick introduction. So this presentation is titled Drones, the Mass Data Problem. Jonathan's here as Head of Survey from Texo DSI, who are part of Texo Group, who are a company using advanced fleet of unmanned aerial and ground-based platforms integrated with latest survey methods and inspection technology, all focused on ensuring precise data capture and analysis, improving project efficiency, whilst minimizing traditional health and safety risks. Very important. And Jonathan has 10 years of survey experience, including with the Ordnance Survey in the North Sea oil and gas sector, high accuracy engineering surveys for cross-rail, topographic and measured building surveying for multidisciplinary consultancies. And all of this has culminated in a role with Texo DSI, who are a company leading the way in UAV survey and inspection in the UK market. So over to you, Jonathan.
Thanks, Matt. Appreciate it. I will just share my screen, guys, and we'll get started. Just let me know when you can see that.
There's nothing coming up yet, Jonathan. Have you clicked the share screen button at the bottom of your screen?
I have, unfortunately, but we see that now?
Yeah, looks like it's coming on now. Thank you.
Perfect, perfect, perfect. Okay, well, thanks, Matt, for the introduction. As Matt alluded to, I'm head of survey over here at Texo DSI. And for those that don't know about us, we are a survey and inspection company based across the UK and operating across the world. So range of industries that we work in is offshore survey, the nuclear sector, land mapping, development, management. So a wide variety of sectors and methodologies that we use. But we're here today to talk about mass data and really the issues and surrounding that in relation to land condition and management. So as a company, we actually operate 26 different types of UAVs, unmanned aerial vehicles, and over 23 different payloads. Much of what has been touched upon within this seminar itself. You have your visual sensors, your LiDAR sensors, thermal, spectral, gas detection payloads, and ultrasonic payloads as well. So certainly a range of different payloads and platforms on which we fly those payloads contributes to giving you as clients the most accurate and up-to-date information, and really at the crux of it all, giving you the best information and certainly the most information to make the best decisions about your site. That can range from topographic surveys, ground monitoring surveys, utilities, engineering, measure building, you name it. And it really feeds into the data set part of big data that Paul had alluded to earlier on in the presentation. So on screen here, you can see some of the systems that we operate. This is actually our UAV LiDAR system. It is a 20 kilogram platform, and it allows us to collect topographic information in some of the most inaccessible and congested areas, otherwise inaccessible via traditional survey. And this enables us to develop contour plots, and deformation monitoring, and so on. However, at the other end of the scale, we operate smaller drones such as the LEOS-2 system. This is a drone contained within a carbon fiber roll cage and can actually go into culverts and pipes as small as 600 millimeters in diameter. So this really feeds into the notion that data can be collected in areas sometimes inaccessible to humans, and more importantly, can provide you with valuable information across your site that otherwise is unobtainable. But the issue with all of that is the amount of data that comes from it. What you see on screen here, each minute of data collection is gigabytes worth of data. It's 4K video that can be streamed back to the controller. And the LiDAR data, even more so, it's billions of points on a surface to develop a 3D point cloud. That is essentially, it's a huge 3D model of an environment, which I'm sure you're familiar with. So that unique blend of ground-based survey and unmanned aerial collection via UAVs. It offers unrivaled capabilities, of course, but how we present, how we interpret that data is the critical element of that. You know, we alluded to the velocity of data coming to you. If you can't handle that as a client, or you can't handle that and use that information to make decisions, then it's pointless, really. And what you see on screen here is a photogrammetric model of a lighthouse that was collected using thousands upon thousands of images from a drone, and then you're able to stitch those together and give you information that you can use to make better decisions about that site. And from that, you're getting your traditional 2D drawings. So that's where you get that blend of how you go from the collection phase to the use phase, or how you gain information from it, essentially, as you can see on screen. So drones also enable us to produce 3D models of offshore platforms, tens of thousands of images, which have been stitched together and registered to produce survey-grade models. And we take these methodologies that are used to create the lighthouse, to create the offshore platform, and we apply those to land mapping as well. Traditionally inaccessible mudflats. This was done as part of a coastal sea defense construction project. A single pass with our UAV LiDAR system here was able to capture millions of points at 3mm spacing on this surface, and we were able to produce a 3D point cloud at low tide, as you see here, of that entire area. And from that, you're able to delve into contour plots, into accurate 3D models developed of the fence lines and structure within the sea as well. Again, traditional limitations of measurement in the survey industry would be, in this case for the cliff deformation, would be the inability of traditional sensors to collect enough information to allow you to gain information. It would also be inefficient, you know, dense vegetation and inaccessible areas, and obviously health and safety concerns for manual access. However, using UAVs, what we're able to do is gather billions of points on those surfaces, stitch together a 3D model, and then essentially you're able to step into a digital twin, which is a real buzzword in the survey industry at the minute. And from that, you're able to obtain 2D contour plots such as this, height shaded digital terrain models. Again, giving your project valuable information, and you know, decision making can be taken from such. It's not just point clouds. From drones, we're able to obtain high resolution imagery. That is incredible. I mean, we're 60 feet above a railway line there, using a phase 1 camera, and you're actually able to read the nameplate on that sleeper. So incredible resolution. However, with that resolution comes the data size. Each one of those images is about 1 gigabyte. So when you're talking about handling that data and how to make use of it, you really need a robust way of doing so. And as I'll show you later, that's something that a client portal such as Texo, and indeed there are others, comes into play. Another aspect is high resolution photogrammetry, an orthomosaic that can be used for site planning, progression, tracking, and land condition as well. So what you see on the left image is actually, if you can see my mouse, this plot right here where my mouse is actually this same orthomosaic. You can see that the resolution is maintained on the zoom. And actually in the top right hand corner, you can see a somewhat interactive demonstration of the portal as well. So moving on from that, we briefly talked about LiDAR. This is the type of data that you're now obtaining from systems that are available. Incredible amount of information that's collected in the space of this project, for example, 30 minutes. and actually being able to handle that and being able to manipulate that is key. Likewise, here for a flood defense project, our LiDAR system is able to penetrate through vegetation. You're able to build accurate digital terrain models. But again, you're left with huge data sets that if you can't interact with and you can't get the traditional outputs from, they're really pointless at the end of the day. Similarly, here, this was a construction project for a highway development in accessible areas, flown with UAV and high resolution data able to be obtained. Other aspects that can be mounted to UV hyper and multispectral sensors. Again, able to cover large areas of land in short periods of time. And we're currently offering the veneer hyperspectral data collection in a variety of environments. You know, the human eye can utilize 3 different types of color receptors for red, green, and blue, but this camera system allows us to detect 270 different unique spectral bands, and that allows for the identification of many materials, and we're able to build those within our in-house library. And this has become a more and more widely used scenario across industries for such as smart data management for crops and field health, as you see here. And again, combine this with LiDAR data, with photogrammetry, as I displayed earlier, and indeed with high resolution inspection imagery. You really get a full suite of deliverables that enables you to make the correct decisions about a project, and you know, that's really what it's about. So the key part of this is how we manage our data. Like just before I go on to that, you know, we realize that we are creating value beyond what's been previously possible as an industry. However, as end clients, you need to have the ability to interact with that data, and you need to be able to gain 2D outputs from that. So whether that be high resolution imagery, whether that be point clouds, whether that be videos, we recognize that, you know, with the sheer amount of data being collected and the speed of that collection, there needs to be platforms that can visualize that to match. And that's something that we've developed here at Texo, and other survey companies have also done, is the industry is now adapting to cloud-based platforms that can manage this data and essentially act as a document control for that. And this video just kind of highlights what's possible now. You know, you're talking about a point cloud that's billions of points on a surface collected in the space of a single flight. You're able to manipulate that, interact with it in a way never traditionally possible. Not only do you get traditional topographic drawings from it, but you're now able to delve into that 3D data and start to interact with it, whether that be point-to-point measurements, spot heights, height measurements, volume calculations. It's at the click of a finger, and that's really where we've got to as an industry. It's how we've moved on from what is traditional 2D outputs, albeit we'll never lose sight of that. We've now moved into that 3D visualization environment, and as I say, being able to interact with this data is key. So that's it from me. Appreciate your time. I hope it was of some benefit. Gives you an insight into what is capable with UAVs and how we attempt to store and manage that data.